start the recording. It'll probably pop up on your screen. You can just hit yes, I accept recording. Otherwise, we will not get to see you today. So a little bit about me before I continue. I'm a robotics and computer science teacher, again, just south of Pittsburgh, Pennsylvania, finishing up my 19th year or so in K-12 education. And this is my third year, again, as a Project Invent Fellow, and my third time emceeing a Demo Day X event. My role today is simply to facilitate and keep things moving so you can hear from these amazing students and accomplished panelists. So before we meet our judges and hear the pitches, and again, I apologize, and I'll probably continue to apologize for all the beeps you'll hear today. We're going to go over logistics. So you should see on the screen right now the schedule. This is about a 2.5-hour event, but don't worry. If you need to take a break, grab a snack, you can. No one's going to notice if you walk away for a minute or two. Just don't do it when your team is up.
Mr. Strine, base period class, please.
All right. So basically how it's going to work is every group has roughly 10 minutes. When the pitches begin, each team of students will have their 5-minute pitch video played. Don't worry, you don't have to do that on your end. I will be taking care of that here. Then there will be about a 4-minute question and answer session with the judges. And then we'll take about a minute to transition into the next one. Okay, so there are a few ways to interact with teams. Check out these features in Zoom. So you have the ability to, oh my goodness, there's so many new features here that I haven't seen before. So let's see here. You definitely have the ability to cheer teams on. So I don't see it on mine, but you should have ability to send a thumbs up, maybe a smiley face, things such as that. Hopefully you do. But obviously you have chat as well. So I see the chat on one of my mini screens on my second screen. But feel free to share things. So if anyone wants to try that out right now, say hello, tell us what state you're from. That would be a good start. Again, my team here is from Pennsylvania. Hint, hint, my team. You should probably write that in the chat. Those of you from Texas, please mention where you're at in Texas. Jerome, I don't know if you can help that individual get into, I think they need to be in the other room. Thank you. All right, so we got Florida, Ohio, Georgia, Oregon. All right, Cleveland, Ohio. I'll reserve my comments about Cleveland while I'm here in Pittsburgh. And Jerome's in Philadelphia. So, all right, with all of that said, we're going to go over a real quick video about basically how Project Invent has impacted students over the years. If you can't hear it for whatever reason, please let me know immediately. I did turn on my Zoom settings to share sound, but I do these enough and it doesn't always work.
We spend so much time, I think, designing for like the 99% of problems, but there are 1% of problems that are really important too, and that's what designing for social good is all about.
Building and creating a product that's bigger than myself. Oftentimes as high school students, we live in our own little bubble, and Project Invent has taught me how to step out of that bubble and create for others. So our community partners are Chloe and Darlene, and they're very unique individuals, and without Project Invent, I would never have had the opportunity to work with them and know what it's like to live as a blind person.
Building empathy for our community partner, that was a big one, because as my teammate has told me, and this like stuck with me, corporate companies, when they build things, they build it for the general population on what they think is going to help. But having a first-hand account telling us I need this and I need that is like, it shows that we're like genuinely going to help our community partner.
I think inventing through Project Invent will help me in my future because it helped me improve my problem solving skills and my social skills, and since we had to do a lot of presentations, so it helped me be more confident speaking in front of people.
Project Event will help me in the future because learning the technology skills that I learned now will help me land a higher paying job.
But now I've come to realize, after doing Project Event for my second year now, I've seen how prototyping is a lot bigger process than many people initially think. It is a lot of user testing, going back to the user, learning from your mistakes, what you could have done wrong, collaborating with your teammates, and most importantly, taking expert opinions on your product and a variety of opinions, even though you might not sometimes agree with it.
It's a fantastic opportunity for you to learn new skills and for you to work in a collaborative environment, engage with a community partner and learn from their perspectives, and understand the true selflessness of a process like innovation.
We spend so much time.
It has taught me.
All right, sorry about the delay. We had announcements playing, so I figured I would spare you for just a minute. Now, without further ado, let's meet our panelists, our judges. As you can see here, we have three panelists today. Our first judge is Chad Marn from Innovation Lab. Next, we have Adam Levinson from Goodwater Capital. And our final judge is Annette Lessick, a library and information specialist and an entrepreneurship educator. So would any of the three of you like to share what you're looking forward to or most forward to today before we get things kicked off?
I'll jump in. I think one of my favorite things about Project Invent is the community partner and the relationship that you form with your community partner. So I'm really excited to see who you all worked with and what came of that relationship.
Yeah, I'll go ahead and go next. I'm very interested in the process, how the journey you took to get to where you are now. I think that's important. So excited to hear all about that.
And lastly, for me, I just can't wait to hear these big, bold ideas to some of these really pressing problems.
All right, thank you all so much for joining us. We have a big task ahead because we have a long list of groups today. We have a dozen groups. This is, like I said, my third time doing this, and this is by far the most teams I've had in a Demo Day X at one time. So now that you've heard from our panelists, it's time for the main event. That means good for all of you. You're going to see less of me and hear more from the students. Okay, this is really all about the students and their journeys, and hopefully we see that captured through their videos and all of their answers to the questions from the judges. So again, it's about 5 minutes for the pitch video, and then 4 minutes for question and answers. Again, this is a quick reminder to student teams. Okay, you've done the hard work. This is actually meant to be the easy part. So breathe while your video is playing so that you can, answer questions to the best of your ability when they come. But realize this shouldn't be a very stressful event for you. It's a Friday afternoon. You've identified your problem to solve. You've designed and probably redesigned over and over again. You've interviewed users, okay, your community partner and possibly others. You've spent dozens of hours coding, building circuit boards, soldering, and so much more. All right, now's your time to celebrate that hard work. Show off what you've done to advocate for your invention, to learn and grow with some of the best professionals in the industry. So again, I stress this, take a deep breath, shake off those nerves, and let's have fun. Again, one last time, after each student team has completed their pitch and Q&A, we will move on to the next team. I will be keeping time, so judges just be aware. I promise I'm a very nice person, but I do need to do some traveling this evening out of the Pittsburgh area. And I'm sure you all have plans too, and our students especially. So I will do our best to keep us moving forward and staying on time. So again, this is a list of the schools and the teams. And we are going to start with Bend Senior High School, which I actually admit thought was in Indiana originally, but I now understand it's in Oregon. We are going to present first and foremost Cycle Sense. It is a solution for keeping cyclists safe in roundabouts. So I can't wait to hear about this because they just built a roundabout in my community.
We are Team Cycle Sense from Bend Senior High School in Bend, Oregon.
We're a class of juniors and seniors from Bend High, and we are in the capstone engineering class.
Our community partner is Christian Williams. He works as a civil engineer for the city of Bend, and he works on the Safe Neighborhood Project specifically for biker and pedestrian safety. In our first interview, he shared the biggest problems were visibility at intersections and lack of communication between bikers and drivers. Roundabouts are very common in Bend, Oregon. Currently there's over 42 and even more in construction. So when looking at intersections, roundabouts became our focus. Throughout the project, we've been working with Christian to make sure our design is effective and efficient while following laws and codes.
So to better understand our problem, we used a crash viewer made by ODOT to research all the bike-related roundabout accidents in Bend. And while deaths were pretty minimal, we found that moderate injuries were pretty high, and we're looking to fix that. As quoted by Christian Williams, lack of visibility is a danger.
We created a survey to gain public insight to our problem and solution. We gave this survey to teachers and students around Bend Senior High School. This survey told us that more than half of bikers and drivers feel nervous when they are in a roundabout with each other. This survey showed us that there is a need for communication both from drivers and bikers to make a more safe environment in the roundabout.
All right, so for our solution, we have decided to make a sign that is triggered by a pressure sensor that when a biker is about to merge into a roundabout, it lights up the sign alerting cars that a biker is incoming. And this way, it decreases confusion between bikers and cars.
Oh, that sign's flashing. Oh, bikers merging. Good thing I saw that.
Designing our sign, we use Bend municipal codes as well as ODOT codes to find allowable sign dimensions, as well as light blinking frequencies, and what colors can be used. For warning, the colors are yellow and black. After using this information, we created two CAD designs, one which would be mounted under a yield sign, and another which would stand alone. We ultimately decided on the standalone design, and we partnered with our metalworking class to create our final prototype, which we can see right here.
The input for our device is a pressure sensor. When a bike is detected from the pressure sensor, it communicates with an Arduino to our sign, flashing lights and warning that there is a biker approaching.
Because the sensor is outside, we designed a box to protect it from the elements and pedestrians.
In terms of competitors for CycleSense, there's not really a lot of other competitors on the market, but there is sort of other infrastructure that does compete with our product, one of which being Dutch-style roundabouts, which are not super common in the US, but they do cost up to $3 million and need a lot of space to get built. You also have pedestrian signs and biker traffic lights as another competitor. These lights are effective for pedestrians but aren't super effective for bikers, as you have to get off and press the button. Our product Cycle Sense is cost effective, easy to implement, and is able to get built on top of existing infrastructure, so we don't have to sort of add extra costs. The only cons is that it is subject to conditions right now, and it's in its prototype stage.
Alright, so for next steps, we're going to use some higher quality materials, make the sign more weatherproof and brighter LEDs. Also use radio frequency communication so we can have 4 signs at each corner of the roundabout to talk to each other. And we weren't able to do it with the timeline given, but working with city officials to implement the sign into a roundabout and test it. And that's Cycle Sense. Thank you for listening.
All right, so judges, we are going to turn it over to you here.
Hi,
Hello.
we're Team Cycle Sense. Yeah. Can you guys hear us?
Yes.
Sweet. Yeah. Just real quick, I just want to let you guys know, we got a way bigger team, but it is senior skip day, so us 2 juniors are kind of holding down the fort. We're gonna do our best to answer these questions for you guys.
You guys are troopers for covering for those seniors. I guess I'll jump in with a question. So I'm wondering, what was probably the most difficult part of the process for you guys? What created the most you know, barriers for you to get through your design process here?
Yeah, so I'll take that one. It was probably none of us have had any past coding experience or wiring or anything with like electronics. So we definitely learned a lot about coding and wiring and just all that stuff. Yeah, soldering, all that. We were more mechanical kind of stuff before, but this has been really fun to learn about.
Great, thanks.
So at the beginning, I couldn't really hear the video too much. Unfortunately, I don't know why, but I couldn't. You were using an Arduino, correct?
Yes.
And so you said you never really coded before. Would you borrow code from GitHub, or were you going into the actual examples in Arduino? How were you coming up with the code?
Yeah, so we used a mix of Arduino code. We went through some different learning with other basic projects. We used some AI to kind of assist us. That was a really helpful tool to kind of debug some stuff. And our teacher also had some experience, so he could also help us there.
So sorry to butt in again, but what'd you do with the AI? What'd you use specifically?
Well, we could ask it, we'd input our code and be like, this isn't blinking at the right rate. How could we fix it? And then it would spit out an answer of different tweaks to the code, and it was really useful.
Good. So that was ChatGPT, right?
Yeah, that's what we used.
Good. Very resourceful.
Yeah, thank you.
So one question that comes to mind for me is how you decided on the pressure sensor for detecting a biker in the first place. Were there other types of detection mechanisms that you thought about and tested, or was the pressure sensor just the best option from the beginning? I'm curious to hear about that thought process.
Well, we were talking to our community partner, Christian, and a few of his friends, for example, Timothy, and he said mechanical buttons were more likely to fail and pressure sensors are more used in like outside world. So we decided we think it would be better to have something that's already outsourced a lot of the time and work with our code to something that would probably be more long lasting.
Yeah, we kind of got the idea since our community partners works in gathering data all the time. They use those air tubes to count traffic. So he kind of mentioned that idea with us and that it's already existing. We know the technology works. It's reliable. So that's kind of how we just landed on that.
Did you ever consider like a vision-based detection system where you have some sort of camera system that sees a biker coming?
We did in the very early stages, but we thought with like weather and stuff, it'd be too hard to implement, especially with our knowledge of coding. And we didn't like it rains and snows a lot here, and we didn't know how we get around that. And we thought the pressure sensor would probably be a better workaround
Great, thanks.
Judges, we have about 30 seconds.
I'll chime in with one last question. So your product is obviously like not going to be on, on the shelves at Target, right? Like it's something that you'll be selling to local governments. Have you thought about kind of your approach to connecting with, municipalities to get your product in place?
Yeah. So we found our idea basically, we talked to Christian and some others kind of similar signs. They cost up to like $100,000. So our sign, without just buying it from like the city, would be about 1,500 to 2,000 per sign. So it'd be a big cost savings. And yeah, our main consumer that would be buying it would be the city, our city of Bend, or any other cities interested in that.
The rate cuts. Should we mention how much it costs?
Yeah. Any other questions?
I just want to say personally, I'm a cyclist. You can probably see the tire in my corner, and I'm in San Francisco, and these roundabouts freak me out. So I love the problem and the solution. Thanks a lot.
Yeah, thank you.
Yeah, thank you.
Yeah, good job.
All right, thank you so much, Team Cycle Sense. I did find a button that I'm going to try to share maybe some more quality sound. I will tell you, it often comes down to the video recording itself because I have everything on max volume on my end. So if you cannot hear it, please just, again, make sure everyone else remains muted when one of the video is presenting. So I do think we're ready for our next group. All right, so group number 2, and you can give me, well, actually, I don't know what just happened, but you can give me a heads up if there's anything. And thank you to group Hug Tight for acknowledging Cycle Sense. That was very well done, and definitely something that I see a need for in my community as well. Our next group is from the Young Women's College Preparatory Academy, and the product is the Massager Wraparound. It is specialized back massager designed to ease the unique challenges faced by pregnant women with Parkinson's.
Our Project Invent by Ashley Yuga, Delilah Castro, and Emily Lopez. For our community partner, we chose Charlotte Juarez, as she was the one that helped us discover the challenges pregnant women with Parkinson's disease went through. Our project ideas. Our first project idea is the back rest, which will make it comfortable to lay or sit down when someone is pregnant. Our second idea is a wraparound massage. We want to create a vibrating massage device that can relieve abdominal back pain from being pregnant. Our third project idea is a hand massage. Creating a hand massager that can help with the hand trembling and maybe even hand cramps. It's very helpful to someone with Parkinson's disease. Having trembling hands can cause problems to someone's everyday life, like writing and holding something. For our topic idea, we chose this topic because as a pregnant woman with Parkinson's, there's many struggles. Our idea focuses on trying to help and relieve stress for pregnant mothers with Parkinson's. We decided to make a back massager as it helps with different Parkinson's symptoms, such as muscle stiffness, hand tremor, and slowness in movement. It helps with muscle stiffness as it helps relaxing the back muscle and relieves pain and stiffness so the person can be able to move around more than rather having trouble as you have back pain. The group this product is directed to is pregnant women with Parkinson's disease. Our community partner once said as having stress is a trigger for Parkinson's. This shows how our product could be desirable as our product helps with relieving stress and pain from the back of a pregnant woman. As we help relieve stress, we help reduce symptoms from Parkinson's disease. How will the user interact with this project? The user will use this by using the Velcro to secure the wraparound the stomach. There will be a button besides the Velcro. When pressed it when it will set a vibration to the back. When done using the product, press the button again and it will stop. This product can be hidden under a shirt, so it will not be bulky. These are our materials being used: spandex flexible cloth, a power knit elastic, Velcro, cotton, and a hook. This idea is novel because many back massagers are not a wraparound. They are bulky, thick, and block-like. A wraparound massager is meant to be hidden under a shirt and able to access. Item: support pillow, back pain relief. Description: it is a lower base pillow that is very thin and soft. Is it durable? It is made of elastic foam and memory foam. Different from our product, it has air circulation and breathable mesh. Price $45.90. Item: memory foam lumbar support cushion. Description: it is a backrest that supports your waistline and your lower back. It releases pressure from your lower back and relaxes your muscles. Is it durable? It is made of cotton and memory foam. Different from our product, it has pockets on the side and it has a zipper for whenever you want to wash it. Price $25.65. Our third item is a wrist tech massager for neck and back. Its description is: it is a back massager that uses heat wraps around your shoulders to relax the neck and back. Is it durable? It uses cushion-type materials to provide comfort and the heat built in. Different from our product, it wraps around the shoulders instead of the back and the belly, and it uses heat to be able to release tension. The price is $50. Our fourth item is a back massager. The description is: it is a back massager that uses heat to relax the back muscle. You can just place it on your back to get a massage. Is it durable? It is made out of plastic and has heat in it. Different from our product. Our products wrap around the belly to be able to directly massage to the back, as the one it just placed behind the back. It also has what in it. The price is $59.90. Questions we have for our community partner: what is the main challenge you think pregnant women with Parkinson's disease go through? Do you think the wrap will be suffocating to the user? Do you think this will relax the user? And will they use it often? Hi, my name is Ashley Lugo. Hi, my name is Emily Lopez. I'm Delilah Castro. And we have created a wraparound massager for pregnant women with Parkinson's. I mean, so speculative, but that's for too much. No, I'm trying to think of it. I'm really dusty face, and I'm like this with this going here is like me and my partner, the ladder caption, comes to me lecture and wrap one shot with some pregnant women and for that her Parkinson's. Now, how does it work? The first character is girls coming on my ear, goes like on, and then you'll hear the sound, which will go off. Then you press on the other side, and that turns off. Here's my business partner now. Okay, so you're showing that our restaurant? Yes. No. We even added Velcro things to make it adjustable. What is this for? This is but this isn't your prototype. This is where the button to be. Okay, so turn them around. And this is our prototype.
All right, thank you so much, Team DAE with the massager wraparound. I'll turn it over to the judges once again.
Maybe I'll start with a question this time. I'm curious if this solution is only for women with Parkinson's or women in general that are pregnant and might be able to find relief from this. Did you think about that? Looks like their microphone is blocked.
This should be good now. If it's blocked, it might be an internal computer issue. I might suggest in the meantime, even to chat, reply your answers so that we can continue along.
They're coming back in the big room with us. Okay, so just talk to this camera.
Okay, do I bring everybody else?
Yes, just answer the question yes or no. Sorry, they changed our student settings. Go ahead and answer the question.
So yes, we did think about other women in this process, but since our partner was more prone to doing Parkinson's, we believe that if we thought about partnering Parkinson's, we'd be more effective of just adding that into the whole point of our products.
Thank you.
I'll jump in as a person who was pregnant not terribly long ago. It is incredible the bodily toll that being pregnant takes. So I commend you for and focusing on a group that maybe, you know, there aren't a lot of tech solutions for pregnant women. So this is awesome. So I want to know a little bit more about like the massaging feature. You mentioned it's a vibrating motor. I'm wondering if you can talk a little bit more about like how it would operate, what it would feel like for the user. And then a follow-up question would be, so the demonstration wrapped it around, so it was kind of active on the back. Is there any thought about like being able to use it in different parts of your body, like wrapping it more deliberately so it goes over your shoulder or other parts, maybe your hips?
So the massager type, since we were limited to using a microbit, the microbit does a sound which allows the vibrating of the massager. And the parts, I feel like expanding more is what our idea was, but since we try to focusing on one feature first to see what we want to do next.
I would also say that postpartum, a mom's body or a pregnant person's body also hurts after having a baby. You're like, you know, you're shrugging your shoulders a lot if you're chest feeding or if you're holding your baby in certain ways. So I could see this product being used postpartum as well.
Yes, we do have an adjustable like sizing. So we did glue Velcro like to 3 different spots because I do know even some pregnant women, they don't show stomach, their stomach doesn't grow out like some do. So it could be used, yes, for postpartum, some women that don't show the stomach where the baby is.
I just got a quick question. Good idea. This is a good idea. Did you confer with like a healthcare practitioner or a nurse at your school to kind of see what they thought of potential harm it could do, if any?
No, we didn't. But whenever we looked up, because at first the product was going to be a whole wraparound massager, and then they said, okay, well maybe it could affect the child inside the stomach if you're doing the whole massager around, and so yes, we talked to our teacher and we did some research instead.
Okay, good.
One more question for you. What did your community partner have to say after seeing your invention?
She did congratulate us on like the good idea of it. But she also did say that maybe instead of doing the wrap around the stomach, maybe do it under, so to hold the stomach up to release pressure.
All right, any more questions from the judges? We have about 30 seconds left.
I don't have any questions.
What was the most challenging part?
The most challenging part was the microbit area, I think, because a lot of us, we are new to this challenge and coding and things like that. And so we are still on our basics. So coding, we did need help from our teachers, other students that are more advanced. So yes, I believe that the coding was definitely the hardest part out of this.
All right, thank you once again, Team DAE, with the massage wrap around. We are going to move on to the next group. Just so you're aware, the next three groups as well are also from the Young Women's College Preparatory Academy, and it looks like they have all worked with the same community partner. So let me go back to our slide deck here. Can somebody just give me a thumbs up and confirm it's back on the screen, because usually I have a glowing green box around it and I don't see that. Okay, thank you. So with our third group, their product is called the Glove. It is a stabilization glove crafted, excuse me, to ease tremors and enhance everyday tasks by providing essential support and comfort for Parkinson's patients.
Cure for Parkinson's. Our team is Chloe Hughes, Janaya Lyles, Michaela Rodriguez, and Isabella Harris. Our community partner is Charlotte Juarez. She is a part of the Davis Finney Foundation and she lives with Parkinson's. Our top idea is a glove to help with stabilization and pains caused in everyday tasks. Why we chose this idea. Parkinson's is a major disease. It causes issues in everyday lives. It lacks of strength, legs, and arms, and it also causes lots of mobility issues. How it works and how to use. The ways to help stabilize the hand and the motor is to help with blood flow, and the glove in summary is to minimize tremors. Market research, what we found weighted gloves just for the palm, glove that only vibrates, and also bulky gloves. What we changed about this glove is we're going to have a glove that covers the fingers, palm, and wrist. The glove is going to vibrate and it's going to be less bulky. Our target users are people with Parkinson's disease or anyone else that relates to having bad tremors or lack of blood flow in the hand. Any questions, please contact us. Thank you.
All right, so once again, we will turn it over to the judges.
Another good idea. I'm curious, what's powering the glove? I know there was a motor, but it looked like in the photo was a micro bit. Is that correct?
I'm sorry, can you repeat that?
I was wondering, was that a micro bit in the glove? I couldn't see it really well from the picture.
Yes, we have a microbit that's going to be inside the glove. We'll probably find something smaller when it actually comes to making the glove. So it's not like because when we tested it, it was like very you could feel it on you. So when we actually go into try to make a real one, we would find another thing to replace it that would still help to run the vibrations that are going to be in our glove.
Okay, thank you.
Is the idea of the glove that the user will be wearing it all the time? Because I see that some of the function is to increase to help with blood flow and to help stabilize tremors. So, and you said it would be less bulky. Do you imagine the user just always wearing it during waking hours, for example?
Yeah, well, if they need to, if they have worse tremors throughout the day, then I think they totally could wear it through the whole day if they need to. But if it's not that bad, then it is gonna be an easy slip on, slip off whenever you need.
I'm curious to hear feedback from your design partner and anyone else that you might have shown this to.
Yeah.
Okay. Okay, so the feedback we received from our community partner is that she enjoyed the idea of the glove, having the motor in it, in the fingers, including the weights to stop the tremors.
Did they get to actually put the glove on and test it and use it in there every day?
She was not able to come back to campus, but we have tested out the glove and used it, and plan on making improvements. And we plan on making improvements like adding in more motors so then the blood flow will be increased and the tremors will be minimized.
Great.
I apologize if you answered this already, but does the glove, whoop, there's a bug. Does the glove detect the tremor, or is it the user that starts to detect the tremor and then they turn it on and it does its thing?
No, so we in our code we had made it to where the vibrations like would start the second they feel like a tremor like gonna happen.
Good. Was that easy for you to code?
No, not really. We had to get our teachers' help a lot throughout the thing to figure out what we were doing.
Well, good for you though. That's a tricky thing to look at. So good for you.
I have a question about the weights. So, how is that? Is it, is it like little packets of sand, or like how is the weight? Like, what is the weight made of? And how did you decide where on the glove it would be?
So we used washers, so it's not as heavy, but once you put the glove on, you will feel it. And she did tell us the certain parts on the fingers, like by the joints near the tip of the finger, where she like has the most pain when she has these tremors or after.
All right, judges, about 30 more seconds if we have any last questions.
Did you have any sense of pricing if this were to go to market? Any idea of like how much you charge and where it might be sold?
Okay, well, we don't know where we could sell it yet, but I did look into like the materials that we would need, and it would roughly probably cost around $15, which I think is a pretty average price compared to others, because usually it's just a compression glove that's sold, and that already goes for like $15-20. So
Good work.
All right, thank you so much to Team The Glove. All right, we are going to now move on to our fourth team. Once again, from Young Women's College Preparatory Academy. Their project was called the Heart Helper. It is a voice-activated robot AI designed to assist individuals with Parkinson's and or paralysis.
Hello, I'm Nancy, the project manager, or I'm the designer. Hi, I'm Maya, the engineer, and I'm Winter, the researcher. And our project is called the Heart Helper, which is essentially a voice-activated robot AI that can perform actions for those with Parkinson's or paralysis, such as grabbing objects and using force. You will say Heart Helper into the mic, which will activate the Heart Helper. The Heart Helper will then grab, hold, or put down objects down for the consumer. Then you will say bye-bye to deactivate the Heart Helper, and the arms will retract back into the center. Our prototype is made out of a cardboard box, and we cut it to be the shape of a heart. We added a base to the bottom of the prototype to help it stand on its own. Holes were cut out on the top, right, and left corners to add the retractable arms. Lastly, we painted its paint to match our theme. We'll be demonstrating our prototype, Heart Helper. Bye-bye. During the process of creating our prototype, we came across a couple of issues. At the time, we didn't have a reaching aid, and that was a main feature of our design. To solve this, a reaching aid was bought, and now our prototype matches the description. Other than just getting the cardboard, we used cardboard because it would properly hold the weight of the reaching aid. To solve this issue, we used a box cutter instead of scissors to make the process easier.
All right, thank you very much, Team Heart Helper. Now we are on to the judges' question.
So maybe you can help us understand a little bit better. This arm helps us grab something or put something down for someone else that might not be able to do it themselves or might need assistance in doing so. Does it stand next to them independently? Is it attached to their body somewhere? Where is this other arm positioned relative to this person?
We're still working on that, but we're like trying to figure out if it can be portable or like if it's gonna be like on somebody's body, you know?
So it would be potentially attached, potentially standalone.
Mhm. Yes.
Heart Helper, I was wondering if you, when you were working with your community partner, was there any specific tasks that they talked about that they could really see themselves using the Heart Helper?
So our community partner talked about sometimes when they try to grab things, they have tremors. So like when they want to like grab something, like say for example, they want to like grab a toothbrush or something, the heart helper could help them do that because the tremors could make it hard for them to like grab the heart helper. I mean the toothbrush.
Is there, I'm trying to wrap my head around this a little bit. Are you able to kind of do like a simulation of how this would work? And you can use the toothbrush example. So if I'm in the bathroom, I'm gonna go brush my teeth and I try to pick up a toothbrush and I start having tremors, what do I do next? What's gonna happen next?
Okay, so since it's voice activated, you would say the words heart helper and it would activate the heart helper and it will grab it for you.
It would grab the toothbrush for me?
Yes.
And then I would just grab it from the thing that's holding the toothbrush, right? The arm, the hand. And then is that also, how did you code that in to that? Is that just, you said it's voice activated. Is that also a microbit?
Yes, it's a microbit for the voice activated.
Okay. They're really powerful little devices, aren't they?
I'm sorry, what did you say?
I'm just saying the microbit's a very powerful device. You can do a lot with them. You have any other plans for moving forward with it?
Yes, we're planning to make the structure more, just not made out of cardboard, just more like sturdy, so it can like hold the arms and stuff. And we're gonna plan to make it portable, so like it's easier to move around.
Gotcha.
Any idea of what sort of material you might use to make it more sturdy?
We were thinking about using something else that's not cardboard, like probably like plastic or polymer or something that's like more sturdy than cardboard. For like, because like sometimes they might want to hold something that's really heavy and the cardboard might break or something.
Plastic's probably a good idea, especially if you 3D print something, you could 3D print it, and they have a certain type of filament now that's flexible. So that could be acting as the joint, right? That might be something to consider, but plastic's a good idea, especially like you mentioned, the PLA plastic that you would get from 3D printing. It's biodegradable, so it's not going to harm the environment either.
It seems like the Heart Helper obviously relies on the voice activation piece as the input, and that's a very important part of it. Is there, do you know of any difficulties that people with Parkinson's might have with their voice at any part? Like, would this maybe not work well for people with advanced Parkinson's, that it might affect their vocal cords? Any consideration around that?
So our community partner, she also mentioned that can we adjust the voice setting, because some people with Parkinson's, it is hard for them to talk because of the tremors of their voices. So we're gonna like try to think of ways so that they can also be able to use it even when they're having tremors within their voices.
That's great. I'm glad she mentioned that. Good.
All right, that about wraps it up for this group. Are there any last second questions? All right, thank you so much, Team Heart Helper. We're now going to move on to our fourth and final team from the Young Women's College Preparatory Academy, and that is Pink Matter. Get back to my slides here. Pink Matter is a weighted glove to aid individuals with Parkinson's disease, particularly those experiencing hand tremors and difficulty with daily activities.
Hello, welcome to our project event project. I'm Orion Cross. I'm Alex Alliance. And I'm Vivica Torres. Parkinson's disease is a brain disorder that causes uncontrollable movement, such as shaking, stiffness, and bad balance on their hands. Our group is creating a weighted glove to be able to help people who have Parkinson's disease that is mainly affecting their hands, making it harder for common day-to-day activities. Community partner. A glove could help instead of using weighted items. What made us choose this call is that our partner Charlotte Juarez said that she would usually buy weighted items like pens, and instead of having to rely on weighted items, she thinks that a glove could possibly help with that. To help people with Parkinson's disease, which is a brain disorder that affects movement due to lack of the bone, causing tumors, stiffness, and slow movement. Our idea is to make a glove that can help with the struggles of day-to-day basis that people face with the disease. When a person with Parkinson's disease is relaxed for a long period of time, their limbs become stiff because of lack of movement. Having a glove specifically for the hand can help a lot with keeping the movement going using weights. The glove is weighted and can help control the amount of shaking and movement of a person's hand. The glove also comes with an adjustable belt, small weights throughout the hand, and the glove is nice and flexible for comfortability. The weight can help people with Parkinson's disease by strengthening muscles, improving flexibility, and enhancing movement, reducing symptoms like stiffness and improve overall movement. And research, we noticed that there are some products similar to our designs, but there is a difference. There are weights on the back of the hands only. There is no weights located around the fingers. There are some that are located around the fingers, but those are more cost efficient. While we're trying to make a glove that is less cost efficient for people that are going and that they'll be able to use it more regularly and aren't ashamed to use it. Another thing we hope to change is to not make the gloves too bulky around the fingers. The Davis Sweeney Foundation has created vital programs, research content, and events for Parkinson's community members, including patients, caregivers, families, physicians, and allied health professionals. Our community partner, Charlotte, is a part of this foundation, and they've helped her by giving her resources to help improve her lifestyle and dealing with Parkinson's. Charlotte is someone that also deals with Parkinson's disease and has communicated some of her concerns and wants that she believes could help her disease. She has a tremor, which means it's difficult to do certain things like writing or motor vehicles and typing. Hi, we are Pink Matter. I'm Adam Samaya, and I'm the project manager. I'm Orion Cross, and I'm designer coordinator.
Well, I'm Vivica Torres, and I'm the team's researcher and tester.
This is our product, Tension Glove. Our tension glove has an adjustable band at the bottom, which can be used to tighten or loosen it throughout the day.
The glove is weighted and can help control the amount of shaking and movement on the person's hand. The glove also comes with an adjustable belt, small weights throughout the hand, and the glove is studded and flexible for comfortability. The weights can help people with Parkinson's disease by strengthening muscle, improving flexibility, and enhancing balance, which can reduce symptoms like stiffness, improve overall movement to the hand.
Something our glove that has some errors throughout the design was trying to find what we could use as weights throughout the day. And we figured that marbles are a good alternative to any other expensive product.
Now that we have that, let's talk about let's talk about our process in the design. So at first, we didn't even think of a glove until we thought carcasses in the hand, so why not do a glove? So our first idea, here as you can see, um, at first we did not plan on having an adjustable belt. And in our second idea, we decided to add an adjustable belt and add small weights to the fingertips of the glove. So this is the inside of the glove. I know you probably can't see it, but like with our prototype, like this would be the inside and the weights would be right there.
Okay. And now you're gonna see our product in testing mode. The sound will sound after how much time?
5 minutes.
After 5 minutes, if the glove doesn't sense movement, it will make a sound like this, and it will encourage you with the little heart to make some movement.
We still have, or that we hope to get some feedback on. Would you prefer something else instead of a belt, for example, a Velcro strap? Do you think there's something we should change that could help you? Do you think this would help more than buying weighted objects?
Listening to our project event.
All right, thank you very much, Team Pink Matter. I will turn it over to the judges.
Hey team, I just wanted to make sure I understood the role of the microbit in your invention. So it seems like, as you kind of covered at the very end of the video there, if it doesn't detect movement for 5 minutes, it will play that little song to encourage the user to move their hand, right? And just wanted to confirm that that is sort of like the main integration of the microbit.
Yes.
Yes.
Awesome. So wondering if your community partner like talked about the need to be reminded to move her hands, or how you came up with like that as a problem that the glove could solve, like the lack of movement for a long period of time.
Well, she said the notification to encourage movement was a great benefit and that it would help her improve her flexibility and reduce stiffness and soreness.
Gotcha. So the function of reminding the user to move their hands, stretch her fingers, it, like, could help prevent future problems. Great. I like that. Thank you.
Following on the thread of the reminder, I think it's really interesting understanding the problem and then an interesting first approach to the solution. I'm curious if there were any other options that might have served as a reminder aside from the noise that you thought of. Like, how else could the user be reminded?
Maybe instead of like sound, we might have could have did like
Vibrations.
like vibrations, maybe like a feel, sort of.
Yeah, I think that might be better, especially if they're out in public and with other people. That's a silent way to remind them.
Right.
Now, I'm curious about the 5 minute mark. Did you do research to find out if 5 minutes was the right number, or is it easy for a person to go in and change it to 7 minutes if they want, or change it to whatever? Or do they have to go into the computer and make the changes and all that? How would they do that?
So when doing research, our partner, she told us that she likes to do constant movement, so we kind of adjusted it to her. But I believe that if we could adjust the code, we could probably increase it to whatever code they need.
Mm-hmm. So that was from her. She thought 5 minutes was a good number.
She thought that probably 5 minutes would be probably good.
Okay. And maybe it, you know, if you do bring it out to market, eventually you would want like an easy dial or something where they can change the time on it. Because not a lot of people aren't going to want to go in and change code, you know?
True.
But for a prototype, that's perfect. That's a good idea. So.
Yeah, I'm going to keep going with this thread because I think it's really interesting. I know that when I have like a reminder notification on my phone come up, I really do a good job of just swiping stuff away or ignoring it to make it go away. So I'm wondering, does the song just play once? Is it possible to have the song complete, like, or keep going until it detects movement? Have you considered, like, not allowing your user to ignore the sound?
Yes. So the sound will keep playing unless you're actually shaking and moving your hand. It's not gonna stop until it senses that you're moving.
Great. So you already thought about that.
Yes.
Did you actually work on detecting the motion? Or is that something that you tried to code and integrate into the product?
We actually did both kind of. When I was making the code, we first tried to see what parts could be detected, and when it was detected, we kind of went on and kept fixing the code and adjusting it to the glove.
So you did, I'm curious what you used to detect the motion. Like what sort of?
Oh, we used a microbit to be able to coding it to be able to detect the code.
So in Microbit, I think it's called shake code, but it's like when you code it and you could shake the microbit and then the computer is just able to tell. So that's what we use when we incorporated Microbit, the shake code.
Great. Now, one more question about the shake code. Can you adjust the threshold? So like if somebody gets, a small, like, what's the word I'm looking for? Where it can make the difference in the vibration, like the intensity of it. Are you able to change that? Do you know? That was the word I was looking for, by the way, was intensity. I couldn't think of that word for some reason.
Can you elaborate?
So when you do the shake code thing in Microbit, are you able to adjust the intensity of it? So like it'll detect if it's a slight shake, or if it's a more intense shake, you know what I mean? In the code, can it do that? Do you know? It's okay if you don't know off the top of your head. I'm just curious.
I believe so, because when we were testing it and at first we would do like a small shake, it couldn't really tell. So I think you have to give more power for it to really tell.
Okay. Now, are you able to adjust that? So if somebody doesn't have, you know what I mean? Like it's easier to detect? Do you know?
We're not certain, but we can definitely look
more into it.
Yes.
Because I know some experience I've had with microbits before, like if you add that shake code to it, sometimes you have to like really shake it for it to detect whatever it's doing.
For us, we didn't really have to shake it that much, thankfully.
Good.
It detected it fairly quickly, actually. After we adjusted the code a few times, it was able to detect it. Thanks to our teacher's help on adjusting our code, she was able to help us figure out how much, like not a lot of shaking or not a little too much shaking.
Perfect. Cool. That's what I was curious about. Thank you.
All right, any last second questions from the judges for Team Pink Matter? All right, well done. I probably speak for all of us, especially the fellows and any other educators on this call. I'm so excited to see so many young women in this competition. It's great to see the last four groups were all young ladies. Unfortunately, the next group up, my group, has all boys. So apologies, but as a father of two daughters, certainly appreciate the work that you all are doing. So continue and strive on and strive forward. So I will get us back to the slideshow here. Next up, from Menneson Middle School, High School, this is Team TSZ Vision. The TSZ 360 Vision Band is meant to alert you about people sneaking up behind you, but it also does so much more.
My name is Cameron. And mine's Aaron. I'm Elliot. I'm Brandon. I'm Rick.
Our project for Project Event is the TSZ 360 Vision Band, and we're presented from Menneson Middle School, High School.
Our client's name is Tex. He is 42 years old and he suffers from PTSD, which is post-traumatic stress disorder.
After interviewing Tex, we learned quite a lot. 1, he does not like when people sneak up behind him. 2, he does not like being in crowded places. And 3, he does not like loud sounds like fireworks or other loud noises.
An anxious Tex need a way to feel comfortable with the surroundings and a way to help him feel control.
When we were thinking of ideas to help Tex, we thought of cameras and motion sensors. He does not like to wear a watch or his hat backwards. That's why we went with the headband. The invention we built for Tex, the TSZ band, is on my friend Rick's head right now. And as you see, whenever my friend Cam walks up behind him, it will go off and alert Rick that someone is behind him. This invention is going to help Tex so much since he has PTSD and he struggles with people sneaking up behind him. We used empathy with our desire to help Tex, who is a friend of the family of 2 team members. We then used curiosity to create a prototype using technology brand new to the team. A fully functional prototype created an ambition that led us to enter our product in another entrepreneur contest where we were a semi-finalist.
While we had confidence to enter the competition, we showed resilience to rethink our design and address concerns that were brought to our attention from the industry experts.
The only thing we could compare our TSC Vision Band to was the Centauri. All their product does is vibrate, which will be coming to our product soon.
A day, we hope to have some funding to buy more Arduino boards, buy snowing materials, and start making revenue to sustain the sales cycle. Got PTSD.
Get the TSZ.
Can't see.
Get the TSZ.
Want to make it attack or flee?
Get the TSZ 360 Vision Band.
Now available at your nearest drugstore.
Hey,
All right, sorry about that. It seems that every time the video wants to start playing again. So I will turn it over to the judges.
so I just want to say this is I like this idea. So you've got the sensor behind a headband, correct? So when you said you did some soldering, did you solder all the componentry, all the components inside the headband? Is that what you did?
So pretty much what we did, yes, to hopefully make more, to put more sensors on it, but unfortunately it wasn't working to how we wanted it to work. It had a slight delay to it, so we're still trying to figure out why that's going on, but at the moment we do have one working.
One that was soldered, right? So you still have your prototype with your Arduino and a breadboard?
Yes.
Okay. Speaking about the Arduino real quick, did you write your own code or did you go out to like GitHub or talk with your professor or your instructor?
So pretty much what we did, we knew how to code a little bit, but we had our team and my teacher looked up online and seeing what we could do and how to code it properly to get it to how we wanted it to work.
So I love the improvements that you made, thinking about the weight and concealing the wires. I'm curious what your partner thought when you presented him the new design.
So pretty much when we presented it to him at first, it used to be big and bulky. And he didn't care for it too much because it was too bulky, and so we made it smaller to where it could fit on his head, and he liked that idea better than having something that would draw a little bit of attention to him he if he was out in public than the headband.
Hey team, I really appreciated in your commercial at the end the way that you called out other possible use cases for the TSZ Vision Band as a, instead of just veterans suffering from PTSD and anxiety. Because when you were presenting one of the places my mind went to is, a person perhaps alone walking down the street, trying to get home safely at night, knowing where if others are around you, it's a safety solution as well. So I know that some of your feedback that you received talked about, well, the beeping might be anxiety inducing for somebody like Tex, but I'm wondering if you thought a little bit more about being able to customize what the output would be and allowing the user to choose, like, do you want an alert to go off, like something aggressive and loud, or perhaps for somebody like Tex, like, yes, you want it to be like calm and not, add to his anxiety. So to recap, my question is, could you customize the output based on the user?
Could, but the thing is, it would take more time to put in the code, and that's why we're working on the buzzer, so it can alert the person without like making them jump or getting scared by it.
So I'll add on to that. So pretty much what it is, it would vibrate, and what we're also figuring, if we do put it out on the market, we would have a site on which you can choose is the noise or the vibrator, and pretty much you can use whichever. And if we had more on each side, it would have different vibrations on which side it's coming from.
All right, any last minute questions?
Yeah, I have one last one. Have you given it thought to maybe use the sensor on maybe like a hat that might send the signal to an armband or something, where they could then be more inconspicuous? Or then, through Bluetooth or something, like something would vibrate on your phone, or not your phone, but your wristband?
So we were thinking of that. Well, not think of that, but we were trying like other products that we presented in the video, and we would try and work on that, but our our text does not like he doesn't wear a watch much, so like any like jewelry and stuff on his wrist, so that can be a problem.
Understood.
All right, thank you very much, Team TSZ Vision Band. I don't mean to toot their horns, but out of 40 contestants, participants in the contest, they did take 4th place. So let's move on here. We are going on to Woodward Academy. So let me get back to the screen. Hopefully we're seeing this. Woodward Academy presents to us the Quack Guard, the duck that keeps your water clean.
Hello, welcome to Team Flint, and we present the Quack Guard, the duck that keeps your water clean. My name's Anish Patel.
And I'm Miles Whitehead.
And we are students from Woodward Academy in College Park, Georgia, here to present the Quack Guard.
For our project, we have partnered with Finding the Flint, an organization dedicated to restoring the Flint River. Despite being the 2nd largest in Georgia and its importance to the wildlife and community, over the past decades, the river has slowly degraded due to pollution and urban development. Finding the Flint attempts to reverse these changes with a massive revitalization effort. In order to make any changes, however, the organization needs information about the state of the river, is tasked us with creating a solution that will allow them to easily collect water quality data. More specifically, our product will be deployed in the green space, a large park-like area open to the public, in which attendees can enjoy the river's headwaters and surrounding nature. Keeping track of the water quality in this park is vital, as many different groups depend on its cleanliness. All forms of wildlife, from turtles to deer, swim in or drink from the river, and the city of College Park also sources drinking water from the river as well, making pollutants a public safety concern. Further discussing the problem with Hannah Palmer, Finding the Flint's founder, we learned more specific details about how it can properly provide a solution. In interviews, she expressed the need for a product that can provide continuous passive monitoring, eliminating the need for manual collection. Tasha Garrison, a spokesperson for College Park, reiterated the importance of maintaining safe water for the community.
This is our solution, the Quack Guard. It's an all-in-one water monitoring system that is able to record water quality wirelessly. It'll be suspended in water and connected to Wi-Fi. It'll also be solar powered, which allows for 24/7 accurate water quality monitoring. What are we measuring for? We're measuring for turbidity. It's important because it indicates water quality in the presence of pollutants, which is the cloudiness or haziness of a liquid, and it can harm the wildlife and the people surrounding it.
The Quack Guard is amazing in a number of ways, but has 2 main selling points that stick out the most. First is that it is a massive time saver. Unlike manual data collection, which requires a paid employee or motivated volunteer to physically go to a location, our product completes this process automatically, saving time and resources. Lastly, it provides access to data 24/7, unlike traditional systems that are only updated every other week. The Quack Guard collects data every minute, with up-to-date info being provided at all times.
The sensor takes in data from the water, which will then go to a microcontroller, which is the Arduino Uno Wi-Fi, and connect to the internet. It will be sent to an access point, which is then sent to a website or a spreadsheet. This will all be powered by a solar panel and battery. This will be housed in a duck-shaped enclosure, and it will blend into the environment, which is also aesthetically pleasing. And the sensor will be located at the bottom of the duck for constant water quality data capture. And it will be float in place by a tether.
Naturally, throughout the engineering design process of the Quack Guard, problems were encountered and many changes had to be made. We ran into countless technical issues that turned otherwise straightforward solutions into drawn-out nightmares. These were very important for us to run into because they trained our problem-solving skills and forced us to be extra careful with our planning. They also taught us about the potential issues in our product's deployment. For example, one of the sensors we purchased was dead on arrival, forcing us to take into account inherent unreliability in project components, teaching us that every completed Quack Guard should be tested to ensure customers receive the best possible examples of our design. We made several design changes as well. For example, we initially planned on utilizing cellular data to transmit our data. However, this turned out to be not very optimized for our partner's needs. Our partner needed this product to save them money, and therefore, a monthly fee could not be part of that. Afterwards, we decided to pivot to Wi-Fi.
This is a demo of how the duck will work. The turbidity sensor at the bottom will take in the data, and then via microcontroller and internet, it will be sent to a spreadsheet, and the data would look like that. This will all be powered by a solar panel and battery.
Naturally, many different organizations and companies have set out their own ways to manually collect water data. However, our design stands out for a number of reasons. First of all, our total price of just $210 is incredibly affordable compared to many of our competitors, such as Enviro DIY system, which is more than double our price at $510. Another major advantage of our competition is our device is incredibly accessible, with a much higher ease of deployment compared to certain competitors. Our product is pre-built and ready to go, while many other systems require lengthy and complicated assembly that requires a great deal of background skill in DIY projects or programming. Lastly, our design is much more aesthetically pleasing, with a friendly design that not only looks nice, but also blends into the environment.
What are our next steps? In the future, we hope to have an increased number of sensors from pH to conductivity, a more modular system allowing for easy replacement and customization of sensors, an SD card to store data and analyze patterns when the Wi-Fi is not available, and a mini OLED panel to display water quality for the people walking in the green space. We also have this in more water bodies. Thanks for watching. Any questions?
All right, very interesting, Woodward Academy. I will turn it over to the judges.
Well, this is great. I'm curious, you're using an Arduino, and so I know the SD card idea is great, by the way. I think that's a smart idea. Just curious, are you using the IoT cloud, Arduino's cloud, for like a dashboard? Like, how are people gonna get the data? Do they have to, so it's coming through Wi-Fi, right? And how far does that go? So if you're using the IoT cloud, right? I don't know if you guys have used that or not, but that creates a dashboard. Are you thinking that far into it where you can easily analyze that data?
Yes, I'll take that one. So how we got it set up right now is that it's going to take in the data, through Wi-Fi, and it's going to print that data through the serial monitor. And we have it set up so that we have an Excel spreadsheet that takes out any data printed from the serial monitor and uploads it to an Excel spreadsheet. So that's how we handle the data collection. And from there, we can use Python, for example, to get that data to a website to allow us to properly analyze it from anywhere. We went over this during our what was it? Our user testing area, I think. We went with Wi-Fi because we had a nearby access point within range of it to handle all of that.
Great. Yeah, I was going to ask about that, how far it would go with all that data. Great.
And for other users, we could use cellular as well. We just use Wi-Fi specifically for a community partner. That was the best choice. For most people, it probably would be cellular.
Yeah.
So you guys mentioned in your presentation that you pivoted from measuring pH to measuring turbidity. Is there any thought to expanding the capabilities of QuackGuard to be able to measure other factors? So that's question number one. And then question number two is how, I know it's measuring on an ongoing basis, but is it like reading it every hour, every minute? And if you made a decision on the frequency of measuring, what was the rationale behind that decision?
I'll answer the second question first. So for the frequency, it depends on how much power it's able to get from the solar energy. In a darker area, it's probably going to have to turn off for a while to charge, and then it'll take the data more periodically. But if you're in a very well lit area, at least during the day, you should probably be able to get relatively instant real-time data from the measuring device. And as for expanding the number of sensors, yeah, that is definitely a plan. The reason we pivoted to turbidity in the first place was because turbidity is just significantly easier to measure and more simpler. pH is probably a better parameter to measure in the first place, but we just this is a very long project, so just to get a prototype done and ready, we wanted to use turbidity first, and that was an important lesson to learn, because we had to ask a lot of other features too for the maybe later stage, after realizing just how hard it is to actually implement your ideas into reality.
Yeah, it was a wise choice. I just thought of another question as you were responding. So I'm wondering, I love the duck, like it's cute, right? I'm wondering if you considered any other sort of exoskeleton for your invention.
Yeah, I mean, there's other animals we can do. We can do a turtle, I guess.
Oh, no, I'm not saying you should. I like the duck, but was that just like the first thought and you stuck with it?
Yeah, we just wanted to be aesthetically pleasing. Another idea was, there's going to be a bridge at the green space, so we we're thinking about attaching it to like the side of the bridge as just like a little box. But we thought that the aesthetics and like environmental blending in that it does provide would be a very good option.
Great.
All right, judges, we have about time for one more question.
I guess a question from me, if you think about the last mile of this product, right, you focus a lot on the sensor and reading the data and pushing the data, but have you thought about how it's actually going to be displayed, what that dashboard might look like, whether there's going to be any sort of alerting for the end user when something is out of range as expected?
The out of range idea is actually a good one, and we'll probably work to include that one. But like I said earlier, it's taking the data and it's going to upload it to an Excel spreadsheet, and from then on, we haven't really decided what to do from there. For now, it's just in a spreadsheet that's like it has a date and the time, which has the data in it, and it just goes through the list. And there's just a lot of things you can do with that from there. Chances are it's going to be in a similar format to that on the website.
Great.
All right, Woodward Academy and the Quack Guard, thank you very much. Definitely like that idea as well. Next, we are moving on to Ginn Academy and the Joey. It is a modular mental health alert device.
Hello, we are the project event team from Ginn Academy. My name is Marcus Caver. This is Kevon Brooks. The other members of our team are Darion Bizel, Caleb Cook, Kelvon Dean, and Kobe Seals.
Our community partner is University Hospital's Color Center for Men. They are a department dedicated to men's health here in Cleveland. They are focused on providing men with comprehensive access to health care with the goal of improving their patients' physical, mental, and emotional health. They aim to improve communication regarding one's health through use of digital tools and services, such as the AgsJo service, which provides increased access healthcare professional.
Did you know less than 50% of men have a primary health provider? Or that men live 7 years less than women on average? Fewer than 50% of men suffering from depression seek treatment. In Cleveland alone, 250,000 men and women see a doctor per year. The Color Center understands that men have a difficult time asking for help. They believe they want their healthcare to be simplified. They consider these things in the design and development of the Cutler Center.
We all know somebody that has dealt with a mental health disorder. Depression and anxiety are major mental health disorders in men. Symptoms include fatigue, restlessness, difficulty thinking, high-risk actions, and appetite and weight changes. About half of men feel more depressed than they're willing to admit. Almost half believe they can solve their issues on their own. If left untreated, these disorders can lead to suicidal thoughts and/or attempts. Men are nearly 4 times more likely to die by suicide than women. It is important that we understand mental health is personal health. The Color Center hopes to provide men with the mental health support they need.
So how can we help men access mental health services? Our invention is called the Joey. It is a modular health alert device intended specifically for mental health support. Most of us have seen those commercials where an elderly person is fallen and calls for help. Our device works similarly. If you are experiencing a mental health crisis, you can activate the Joey. With the click of a button, within minutes, a personalized representative will call you to provide support at your time of need. Help is only a click away.
The Joey provides quick, easy access to mental health support without asking the user to look up specific contacts or to wait on hold. It would allow the user to pre-select who they would like to speak to during a mental health emergency, whether it's a mental health specialist, a personal contact, or a support hotline. The modular design allows the user to decide how they would prefer to use the device, as a wristband, a necklace, or even a keychain. Overall, the Joey would increase access to mental health support services at a critical moment.
The Joey consists of an OLED display, button controls, Bluetooth communication. The 2 buttons act as inputs while the OLED and Bluetooth act as outputs. Where button 1 press the OLED will display a message asking if a user they need help. If they require help, they press button 2, which sends a message via Bluetooth to a paired cell phone. The cell phone will then forward the message to a designated support contact through the use of an app that we plan to develop. Upon receiving the message, the recipient will call the user and provide support. Here is a Joey in action.
The next steps are to design the modular enclosure and fixtures for the Joey. Develop an app that forwards the Bluetooth message via text. Conduct a trial run with a group of color center patients and develop support line contacts among healthcare professionals and support hotline services. Thank you.
All right, thank you very much, Team Joey. Sorry, let me pause the sharing here. And once again, I will turn it over to our judges.
Great. Maybe I'll lead off. This is really exciting. I know it's a big problem all over the world. So very important thing to be focusing on. I'm curious if you worked closely with any specific users that might have mental health struggles like depression or anxiety, and just hearing about like what sort of problems they go through day to day, week to week, where they would need immediate assistance and support.
We have met with a few, the Cutler Center team, myself, and other people like who have gone through experiences with depression, because at sometimes when the depression be dressing, it really be affecting us and all. So we have many experiences with many people who have been through experience with depression be dressing.
And so do you have any examples of, maybe a better question, when you do push this button and you get on the phone with the support person, what sort of conversation is it? What are they helping you with?
Depends on what situation you are going through. So you got the panic attack. You can just like, when you're having a panic attack where you really want to go through your phone and then try to call someone specifically and then have to look for their number. Then if they're not answering, then you gotta call them again. But this helps people who, like if you want a specific person, then that's gonna still be a problem. But if you just want someone who's just available anytime, you can just click the button and then you can just get them right then and there.
Yeah, I think panic attack is a very good application or situation for this application.
Or when you're at the end of a rope and you really just don't feel like you can take it anymore, you can talk to someone just right in there as well.
Yeah, thank you.
Yeah, really, really clever idea. I'm curious how the call is routed though after somebody presses that button. How is it? It's going from the device to the phone. Did you use like App Inventor or something to get it to go to the phone and then dial out?
We use MIT App Inventor.
Okay, yeah, that's what I figured. I haven't, yeah. And so, but how is it routing to a certain number? How are you doing that? Is that all through App Inventor as well?
Yes.
And what happens if it goes to that number and there's no signal? Does it go to does it have another one in queue?
Yes, because we're not going to give it to one person. We had to have like multiple people available because
so it just goes
anything can happen.
Yeah.
Guys, I gotta say, your research was so thorough, and as a librarian, I really appreciate seeing all of that data in front of me. It really was impactful. So I gotta say, just another point, I think that as you've explained to us that men have a hard time reaching out for help, and the button makes it just such a low bar of, you know, performance, or a low bar of like action for the people who are in a difficult place to need the help. So I think that's really great. So I guess I wanted to kind of follow up on understanding how do you determine who would be receiving the message, the request for help? So would the message be going to emergency services? Would it be going to the individual's primary care, or a family member, or a therapist? Like how do you determine who receives the message? Yeah.
User specific
Okay.
is all about who you want to, or if you can, more of a default can just be the Cutler Center.
Okay. Gotcha. Gotcha.
All right, we have time for about one more question. All right, team, the Joey and students at Gann Academy. I could let you talk all day about this. I'm very open about living with mental illness. I had a team work on a very, very similar invention last year. I'm going to be sending you a direct message with my contact, so please look out for that. But congratulations, and keep doing this kind of work. It needs done more than people will ever sometimes realize. That brings us to our ninth team, so we're about 2/3 of the way done here. The team, I'm not sure if this is a school or maybe a community group, but it is Tech Sassy Girls. So let me go back and share. The product is called Red Light, Green Light, and it is a sensor used to determine if a bathroom stall is occupied.
Have you ever walked in on someone using the bathroom? Well, in that case, we have a solution.
This is our project that we've been working on for the last 2 months. This is our solution with our sensor. Once you press it, there's a light sensor. The light sensor detects if the lock in the bathroom is closed. When the door locks, the light is blocked from the sensor and the LED will shine red. When the lock on the door is unlocked, light will enter the sensor and shine green.
Another feature this project we've done has is a button that's connected to a buzzer. When a person enters the bathroom, they can also press the button and the buzzer will go off, making 2 different sounds to indicate whether the bathroom is occupied or not. The use of the light and buzzer make a project more accessible to people with either hearing or seeing disabilities. This project is a lot like a vending machine, if you like to think about it that way. There's the input, there's the output, and there's the command. The command would basically be a machine telling which holder would start spiraling and which drink would come out. The output is you receiving the drink. For this to work, there's a light sensor. If you block the light, it turns red. If you shine light at it, it turns green. There's a button in the output in case you have a seeing disability and can help identify whether the bathroom stall is vacant or not. If it is occupied, the buzzer will buzz 2 times. If it's vacant, it's just 1 buzz.
One problem that has happened to me, I've put my backpack on the hook of the bathroom, and when I did that, the door unlocks, and then somebody just pushes the door, and you just try to stop them from opening the door, right? So if they see the light, that would stop them from opening the door and also hear the buzzer. When you don't have a lot of time to go to the bathroom in between your classes, it also saves you a bunch of time because you don't want to just sit there and opening doors to see if somebody's in there. The light helps you indicate if somebody's in there, and the buzzer also helps with that too.
This has been the project Tech Sassy Girls has worked on for the last 2 months. We really hope this helps other people, as this has not only been a problem for us as middle school students, but I'm sure elementary, high school, and even workplaces have problems like these. Thank you for watching.
All right, yeah, definitely a problem. I think we're all in agreement with that. So let's turn it over to the judges for questioning.
I'll jump in and ask, so, you tested and kind of designed around the environment of a school bathroom. Where do you envision red light, green light being implemented? What types of other places out in the world besides schools?
So apart from schools, we were thinking about malls because most of these bathrooms are public bathrooms, which almost everyone uses. So it gets really awkward in there, sometimes even crowded.
Yeah. Yeah. I was thinking about like airports and amusement parks. Like one thing I appreciate about your invention is like the ability to do that quick visual scan if you do have vision that like, you're trying to get in and out of that bathroom really quick, or if you're trying to make it to class, right? So I really appreciate the time saving aspect for the user.
Yeah. We wanted to include not only those with disabilities such as missing their eyesight or missing their hearing, since a lot that can be really common nowadays. So
thanks.
I'm curious to hear about some of the challenges you faced when coming up with this design.
So one thing is that none of us are really experienced with technology that much. So it was hard to start learning it at first, and we only had 2 months to do this. So it was really hard to just catch up with everything and work it through. But in the end, we did our best and just overall give it our all.
Well, you did a really good job if you've never really coded before, so that's not an easy task. I'm curious too, have you thought of maybe like creating like a grid? You know how like you go to park at an airport, for example, and you go up to floor 6 and it says there's 6 parking spaces available. Obviously people without sight wouldn't be able to see that, but you would walk in and at least say, okay, there's at least one stall open, and then you would walk up to the stall and it would buzz if somebody was in there. Have you given that any thought?
We haven't really given it a thought, but it could be implemented into our project. There's always room for improvement and how to like change it for the better, you know?
Absolutely. Yeah.
Have you thought about the implications of putting a technology device inside of a bathroom stall and whether people would be comfortable or uncomfortable with that?
So in my point of view, a lot of people would be probably against it since they're like mistrusting, maybe thinking that they want like information or like recording stuff like that, since in the way our world is today, there's a lot of that going on. But in reality, for those who aren't able to really tell or are usually busy to the point their mind blacks out, I feel like this would actually help out instead of taking a few steps back, you know?
Is there anything you might be able to do to make people more accepting of something like this in a bathroom stall?
Um, so it's mostly a motion sensor, motion and light sensor. Sorry, light sensor, right? It's a light sensor, so even if it's directly told from someone who's built it, there's always people who will mistrust it. There's always people who are gonna judge it, and I feel like at that point, it's just a moving forward and just block out the noise and focus on what you're doing.
Yeah, I think the difference between motion and camera is really important, and making that really, really clear to people.
Making it clear to people is something that would be important in making them trust this product more, as a lot of people these days, as I said, aren't really the type to just blindly trust things. So
making it clear to people, like showing them how it works, how it's constructed, would maybe gain their trust a bit.
Thank you.
Any more questions, judges? All right, that brings us to our next group. First of all, thank you very much, Red Light, Green Light. Tech Sassy Girls, looks like you're from down in Florida. Thank you again for sharing, and we will move on. I believe the next three are from the same school, our last three. So let me get back to our slide deck here. First up from Athens Drive Magnet High School, we have Scribblemate. It is a pen that creates independence and confidence in kids who struggle with handwriting.
Dang, I messed it up. Meet Peter Flory, a remarkable 13-year-old grappling with hypertrophic cardiomyopathy. Peter's heart condition necessitates homeschooling, but it's not just his health that poses challenges. His fine motor skills struggle to keep pace, hindering his handwriting and academic progress. But within Peter's challenges lies our inspiration.
This is Peter's handwriting compared to the average 13-year-old's handwriting. And as you can see, the task poses a significant challenge for him.
Handwriting isn't merely the act of forming letters. It's a complex mix of muscle strength, cognitive abilities, and visual perception. Suzanne Stamfa, a dedicated occupational therapist, states its pivotal role in education. She states that children from kindergarten to second grade learn to write, and from then on they write to learn. But for 30% of children in the US, this is a major struggle. That's 21.75 million kids in the US alone.
We've been inspired by compelling research demonstrating the effectiveness of finger writing interventions for children with developmental language disorder. Children who write with their fingertips have showed overall improvement in their normal handwriting. However, currently, the only way to do this is by using paint or special chemicals in paper to write, and this is just not an option for everyday learning. After talking to an occupational therapist and observing Peter, we noticed many writers also struggle with spacing. As you can see, Peter's words are often written on top of each other due to a lack of visual perception. These two main research points of grip strength and spacing inspired us to create a fingertip writing device with spacing assist technology.
In a world where every child's journey in education should be met with encouragement and support, our device emerges as a beacon of hope for those struggling with handwriting. Our pen is not just a tool, but a companion fostering independence and confidence for those facing challenges like Peter.
By affixing to the pointer finger, Scribblemate empowers effortless writing. Scribblemate is fully adjustable and eliminates the need to hold the pen, allowing individuals with reduced grip strength to be able to write. And here's us writing with our prototype of Scribblemate. Its integrated light beam provides a visual guide ensuring consistent word spacing. Once a word has been complete, the user pushes a button providing a visual guide of how far they should space their next word. The user slides their hand to the right, matching the light beam with the end of the last word, ensuring consistent spacing. Write the word, press the button, slide your hand to the right, matching the laser with the end of the last letter of the word, then continue writing the next word. Scribblemate features a bendable pen for ease of use, a refillable ink cartridge for reusability, as well as an adjustable strap so that it fits all. With curiosity towards Scribblemate's effectiveness, we tested it out on our left hands. Our whole group is right-handed, and as you can see, Scribblemate tremendously improved our left-hand handwriting when compared to a regular pencil.
In our quest to revolutionize handwriting assistance, we've evaluated existing solutions. While dictation software eliminates script and spacing barriers, its complexity proves daunting, especially for children with speech impediments like Peter. Weighted utensils offer grip support but fall short on spacing assistance. Pencil grips are a one-size-fits-all solution as they might not address the specific needs of every child as they do not feature a modular design. Scribblemate surpasses other solutions by offering a unique approach that tackles both grip and spacing challenges for children of all abilities, fostering a more inclusive and successful handwriting experience.
With an eye towards continuous improvement, we envision automating Scribblemate's spacing assist system. Through seamless integration, the light beam will project automatically, eliminating the need for manual activation. With a bigger budget, the innovation promises to redefine accessibility in writing assistance.
Scribblemate isn't just a product, it's a testament to our commitment to inclusivity and empowerment in education. As we continue this journey, guided by Peter's resilience and countless children like him, we remain focused on our journey to unlock the full potential of every child, one letter at a time.
All right, very well done, Scribblemate. I will turn it over to the judges.
So really impressive. One of the things I really liked is how you showed the side-by-side comparison of non-dominant hand without and with Scribblemate. I'm curious how you might plan to test the efficacy of your product even further to prove whether it's really going to help the specific users you had in mind.
Yeah, so we'd like to be able to give it to children with poor handwriting and then be able to compare that, their writing with Scribblemate to their original writing. And we would do that by going to different occupational therapists at schools and offering our product.
Great. I think that's a great idea.
Definitely a really good idea. Annette, did you want to go?
Sure. Awesome. I love the simplicity of the device, but it seems exceptionally effective. So really exciting. So a couple questions. Did Peter himself get to try it? So that's question number one. And then question number two, the spacing feature, the spacing guide with the light. I'm wondering, I think I missed what the input is. Is it a button for the input? And then is the light gone after you release the button, or is it on a moment of time? I'm just wondering, like, will the person have to keep holding the button and then slide their hand over and then release to continue writing? And sorry, I guess I do have a third question kind of wrapped into there. Have you considered spacing between letters too? Because right now you're spacing between words, which is super important, probably more so than between letters, but is that also something you were thinking about?
Yes, so unfortunately we weren't able to test our device on Peter. That's why we tested using our left hand, because we weren't able to pull him in. But in the future we would love to test that because we have a couple of samples of his normal handwriting, and that'd be really cool to see the side by side. In the future, we do plan for the output or the input to be like automated using like a integrated like technology. As of right now, yes, you do have to click a button, which is a manual input. We would like it to be automated so that children don't have to have that added complexity. With more time, we would add that. And then for the spacing between letters, we haven't addressed that yet, although by looking at Peter's handwriting, he didn't have issues spacing between letters. And even when you look at young children's handwriting, it's not between the letters, it's between the words. They just don't see the difference.
Got it. Thank you. Great answers.
Thank you.
So I'm just curious about so the prototype is great, right? You've got your proof of concept, it's working. I love it. Have you given it any thought to, getting rid of the breadboard? Because I noticed when you were doing the spacing, the breadboard kind of came with you. Obviously you can give it longer wires and that sort of thing. So have you given any thought to how to integrate all of that within the device?
So if we use a smaller microcontroller, right now we're using the Arduino Uno. So we have to have like that extra breadboard because the positive and negative charges, it kind of make just using the breadboard just makes it more simpler.
Yeah.
Just to code it out. So if we just use a smaller microcontroller and we have little just more inputs on that microcontroller,
we could like possibly just eliminate the need for the breadboard itself.
Yeah, I was thinking maybe like an Arduino Nano or something might work. Because it's really the code shouldn't be that tricky, right? Because it's just kind of sensing where the word ends to the next one.
Mhm.
Yeah.
So that might be something to look at, and you've got the code already, so it might be an easy change.
Yeah, that and then combining both, as you saw, we had kind of two models. Being able to combine those two was part of our next steps. And to do that, we'd need to make the technology much smaller.
Yeah. Good job.
All right, thank you very much, Scribble Mates. We will move on to one of your partner groups at Athens Drive Magnet High School.
Thank you. Thank you.
You're very welcome. Great job. All right, the next group is making a project called Cardio Shield. It is a comfortable and safe way to protect medical implants.
Hi, my name is Thomas.
I'm Chakran.
I'm Aaliyah. I'm Alice.
And this is Cardio Shield.
This is Peter. He's a 13-year-old boy who enjoys playing baseball and various other outdoor sports. He has a medical condition known as hypertrophic cardiomyopathy, which thickens the muscle of the heart. Because of this, he has an ICD. An ICD, or an implanted cardioverter defibrillator, moderates his heart rate and sends electric pulse to the heart in the case that it ever stops beating. It appears as some sort of bulge underneath the shoulder. 800,000 people currently have ICDs in the US. While playing baseball, Peter must wear an ICD protective cover to make sure it doesn't get damaged or fractured. His current ICD protection, unequal, doesn't actually cover the ICD itself. He has to cinch it up in the back, making it uncomfortable to wear and even more uncomfortable to play in.
To solve this problem, we originally thought of using a single strap, an asymmetrical shirt, or a sticker design to support the pad. Our team has worked hard to create our final solution, Cardio Shield. It's built to prevent damages done to an ICD so that users can live life to its fullest and be confident that they are safe. Cardio Shield will also determine if their ICD has been fractured to alert them of risks to their health.
Our pack consists of a hard-cover shield with foam in between the pressure sensor. The light right here indicates any heart pressure that could potentially fracture our ICD. And to put onto our final product, you just slip it on right here, or wherever the ICD is placed.
This microcontroller is coded to alert the user with an LED light when enough force is applied to the pressure sensor. For this demonstration, only a small amount of force is applied, but this can be altered for the final product, so that only enough force to break the ICD will turn on the light. Competitors is the brand Unequal, which Peter currently uses and is unsatisfied with, as he has to cinch the back to fit it to his needs. It's currently $100. Another brand that does something similar to us is PaceGuard. Though theirs is more geared towards pacemakers, they still do something really similar to ours. The total price for that is $125. The total estimated cost of Cardio Shield is $75, excluding shipping and tax. Comparing ourselves to our competitor, Cardio Shield wins in comfortability. We use strong yet comfortable nylon straps to the minimal level. Unequal and PaceGuard both are full-on shirts, which would be uncomfortable during physical activity. Cardio Shield is also more cost-effective than the other ones, as they're in the hundreds and Cardio Shield is only $75. Cardio Shield would be easier for Peter to put on, as we know that he has slight mobility issues. Although he can put on Unequal and PaceGuard, he does require a little assistance, as shown before. Cardio Shield would be easier for him to just slip on right before a game. Cardio Shield lacks a bit in security compared to the other brands, as it is straps and the others are shirts. But we make up for what we lack with our microcontroller pressure sensor, because it alerts the user whenever pressure is applied to it, which may cause them danger. We'd like to be able to customize the size of the protected area so that we can protect larger implants or the entire heart. We'd also like to be able to branch out into helping those with other medical conditions. And we'd like to also create ways to protect other areas of the body so that we aren't just limited to the chest. We can also see the technology being used in Cardio Shield being implemented in other products. Cardio Shield is a comfortable and safe way to protect medical implants.
All right, Team Cardio Shield, thank you very much. We will turn it over to the judges for questions.
Hey team, I'll jump in first. So I'm curious to know more about the sensor. So it's a pressure sensor, I understand that, and the output is a light. So I'm wondering, can you clarify, like, where is that light displayed? If a person like Peter is out playing baseball, is it cumbersome for him to see the light? Does he have to like get under his shirt? Like how are you making sure that the output is noticeable?
So the light is kind of situated on the outside of the actual pad, right below his shoulder kind of area, and that's definitely a great question, because it is meant to be underneath like maybe a jersey that they'll be wearing while they're playing, but it should be able to shine bright enough to be able to see maybe through the jersey, or if not, yeah, they will be able to kind of check it. If they have been hit by a ball, that's usually when they'll kind of need to double check that they are still safe in that area.
The light also stays on, so it's not like it turns off automatically after it like alerts the user. So it still stays on after. So like if he's taking off his jersey after and he sees, oh, the light's on, then he could get it checked out and stuff like that. So it's not like an automatic like thing that turns off.
That's a great clarification. I appreciate that. Yeah, so he can at least like realize that at some point it was activated and he can check his device. I also think a lot about blood continuous glucose monitors that folks with diabetes wear, if there might be a possibility to send the data from the Cardio Shield to like a parent's phone for, if it's a child that we're talking about. So I wonder if you considered sort of a way to share the data or share that something has happened beyond the light.
Yeah, we originally did think about that like a notification. We were thinking like a notification to a doctor or something like that, like, hey, your patient has been hit with this thing or something like that. But we just stick with the light so the user could like choose for themselves, like, hey, unless it's like a malfunction or something, hey, I've been hit, I need to go check this out.
Great, thank you.
I'm wondering too, I do like the idea of sending it remotely to somebody. That would be really helpful, I think. I'm curious too, maybe, with the light, did you consider haptics where like something might vibrate if there's some pressure?
That's a great idea. It's something we can definitely look into. But it is where the microcontroller is, it's kind of inside the pad area. So there's kind of things on both sides of it. So it might not be very obvious if it were to vibrate or something like that, but that is definitely something we try to figure out.
Also, vibration would be a lot less visible to people watching him. Like
it would notify him too, right? I mean,
right.
Yeah, so having both might be good.
Yeah.
Cool idea though.
Thank you.
Really.
So one question is around durability I had, right? We're talking about getting hit by a pitch or hit by a baseball coming off a bat. So did you get to test the current products that you're using, whether they would stand up to that sort of force?
So we have straps on, so it's like a harness, as you guys saw earlier. So it won't like be thrown balls in, it won't like fall off, but definitely like the light will also indicate if like it was a 2-hit pitch or like the ball just went too fast and stuff like that. So it won't necessarily fall off because the straps are also held by strong Velcro, so it won't just like fall off.
Yeah, we didn't have the time to necessarily like test actually impacting the pad as hard as it would with the baseball in a game, but we can assume that even if it were to break, it would be protecting the ICD underneath, which is our biggest goal here.
That's a good point.
All right, thank you so much, Team Cardio Shield.
Thank you.
Thank you.
You're very welcome. All right, this brings us to our 12th and final group. And once again, from Athens Drive Magnet High School, we have Team Hug Tight, which is on-the-go automated compression to ease anxiety.
In today's world, stress and anxiety have become increasingly prevalent. According to the World Health Organization, over 301 million people globally suffer with an anxiety disorder of some kind. Stress is a skyrocketing epidemic, even past the people with diagnosed anxiety disorder. With the world market of anti-anxiety drugs being worth over $15.23 billion, our group wanted to create an alternative means of output that could help the user calm down and feel ready to reconquer the moment.
I'm Luke.
I'm Tegan. I'm Maddie.
I'm Paolo.
And we are Hug Tight.
Our community partner and inspiration for Hug Tight is Peter.
Peter has a heart condition named hypertrophic cardiomyopathy, a disease in which the heart muscle becomes thickened, which makes it difficult for the heart to pump blood.
This has affected his day-to-day life because Peter is homeschooled and has to worry about many factors in his life that most kids his age don't have to think about. When we interviewed Peter and his family in person, we noticed that Peter was fidgety and pulled out his hair and picked at his fingers.
I'm always doing hair pulling.
Getting to know Peter better, our group conducted a variety of experiments for the purpose of gathering information on what type of device would suit Peter best at reducing his stuttering and anxiety. We initially considered a stutter detection bracelet with LED cues, but coding complexities and LED triggering issues led us to abandon it. The weighted tapelet, inspired by compression therapy, was rejected due to portability concerns and potential self-consciousness for the user Peter. However, we extracted components such as LED lights, sensors, and compression therapy methods from these concepts, ultimately leading to our final product idea.
Our solution is a wearable device that pulls inspiration from the concept of artificial muscles and implements compression therapy. Ultimately, our device issues a squeeze on the upper arm and shoulder area, with a sensation similar to using a blood pressure cuff in the doctor's office. Hug Tight works like an artificial hug or an anchor to help calm the user down.
Hug Tight operates on an input-output framework. The input for our device is our heart rate sensor, the output is our compression technology, and the management is the PWM circuit.
According to the Harvard Medical School, resting heart rate is impacted by stress and anxiety. And when heart rate exceeds that threshold of 130 beats per minute, it could signify that the user is stressed.
Hug Tight has a built-in heart rate sensor that continuously tracks the BPM of the user, and when BPM exceeds that certain threshold, it would activate the PWM circuit to compress the sleeve and light up the signal LED. We use artificial muscle fibers to compress our sleeves, making our own nylon muscles out of fishing line. The fishing line is coiled, stretched, and annealed. This process allows the nylon's elastic nature to contract itself under heat and return to its original state when cooled. The PWM circuit uses a 555 timer to regulate the duty cycle of the power signal and let the user toggle the level of compression they desire. The three internal 5 kilo ohm resistors inside the chip are used to compare the voltage inputs and generate an AC signal. This signal is then fed through two MOSFET transistors to amplify the current, heat up the wire, and control the compression as fit.
In an interview with Wake County's head occupational therapist, Suzanne Stanfa, we learned that the application of pressure to specific parts of the body helps to provide a sense of being hugged or held. Furthermore, compression provides a sense of security and stability, and it also helps to reduce heart rate and improve mood.
Hug Tight offers unique anxiety relief with its portable design, unlike medication or weighted blankets. It provides rapid effectiveness through compression therapy, yielding results in just 8 seconds. Its heart rate monitor also ensures pinpoint accuracy for proactive stress management throughout the day.
We want to include a heat-resistant fabric layer underneath Hug Tight's technology to provide comfort and protection for the skin. We want to conduct further testing to ensure the safety of our product as well. We want to build towards a sleeve with fully automatic compression, one that can provide personalized compressive support for each individual's stress threshold and preferences. We want to explore how the further production of artificial muscle tech could impact the field of compression therapy and anxiety treatment. We want to pursue the marketing of Hug Tight with its estimated cost of about $50.
In conclusion, Hug Tight offers a novel and effective solution to anxiety with its portable design and rapid effectiveness. By integrating compression therapy and real-time stress monitoring, Hug Tight enables users like Peter to confidently manage their stress anytime, anywhere.
First
All
off,
right, thank you very much, Team Hug Tight. We'll move on. Oh, I'm sorry, Chad. Go ahead.
No. I just want to say congratulations. This is great. My first question is, I'm a big electronics nerd, obviously. How'd you find the 555 chip? Because that's a great IC. So.
Thank you. Yeah. So I've had previous experience working with the 555 timer, and I just had, some leftover, so I figured may as well.
Perfect. Yeah, we've been using the 556 chip in my music classes. So yeah, great choice. So yeah, good work.
Cool.
No real question though.
So it sounds like you went through a lot of different iterations before you land on the ultimate solution. I'm curious, what was that experience like, and what was like the key learning that led you to this final solution?
So it definitely posed our biggest challenge when we had to decide on a path, like decide on a specific path. And we learned the design process and like the importance of the feedback stage and going back to the whiteboard and bouncing ideas off of each other. And I think through the process of like exploring our different initial ideas, we were able to kind of figure out how as a group we could work together and compare the pros and cons of each. And I don't know if you can see it in the back, but we have like a lot of charts here of our design process. It definitely taught us about like how we can rank things on different categories and stuff like that. So all in all, like with the initial ideas, we learned how to improve our teamwork and use feedback to kind of narrow down on what our final goal would be.
Great, thank you.
Yeah, it was really cool to see the previous ideas that you explored and sort of the effort that went into those and what you learned and came away with from those invention ideas and how you were able to kind of incorporate some of that thinking into Hug Tight. So I'm wondering if you could talk a little bit about the choice of making it kind of like the upper arm sleeve location. Like, was that did that feel like it was just the right place versus maybe around the chest? Because I'm thinking about the name of your invention. I don't necessarily feel like your arms are, I mean, you're squeezing with a hug, but I feel like, it's felt more around the trunk of a body. So just tell me more about the choice of the upper arms.
Yeah, of course. So we met with head occupational therapist Suzanne Stamfa, and she really helped us kind of pinpoint the most effective parts on the body where compression therapy could be at its peak effectiveness. And those three areas were the hips, the jaw, and the shoulders. And like out of the two, I don't think anyone wants to wear like a head wrap that like squeezes the head in. So we really did we already initially had the ideas of the arm, but with meeting with Suzanne Stamfa, we were able to target that upper arm. And yes, like Hug Tight, when you think of a hug, you usually think the trunk, but we were thinking that kind of squeeze on the shoulders. And if you like put a weighted blanket on, you feel that kind of just that comforting hug feeling, hug sensation.
Absolutely. Great answer. Thank you.
Thank you.
Thank you.
All right, awesome job once again, Hug Tight. Thank you very much.
Thank you.
You're very welcome. That concludes our pitches. So I do not envy the job of the judges at this point. Congratulations once again to all of our fantastic and brilliant students. Certainly the fellows involved in the network of teachers that are out there promoting design thinking, mentors, and any family members that may be on this call as well. Our panelists will now head off to a breakout room where they're going to have time to deliberate and decide on our 4 awards. And the rest of us are going to sit tight and be in for an incredible treat with our keynote speaker, followed by some highlights of this year from some of the teams. With that said, let me move on.
Oof.
To introduce our keynote is Dr. Tahira Reed-Smith, an associate professor in the School of Mechanical Engineering at Purdue University, and she is also the director of the Research in Engineering and Interdisciplinary Design, or known as the Reed Laboratory. Dr. Tahira, the floor is yours.
Hi, can everyone hear me okay? Yes?
Yes.
Perfect. All right, so I'm going to be sharing screens from another computer, and let's do that right now. Okay, so if you could stop, well, I could take over. Yes, it says right here. Let's get into the presentation. And can you all see? Well, I can see over here. All right, perfect. All right, so I'm excited. I'm an adjunct now at Purdue, but moved to Pennsylvania State University. And I'm excited to be here. First of all, let's just start out with some praise. I witnessed you all do some very difficult things. I know that first of all, the design process alone is challenging. And if you had infinite time, I'm sure that you would have come up with several other iterations of things. I bet some of you ran into challenges, whether with the project or within your own lives, all of that. But yet, you've done a phenomenal job. And even presenting your work, I know how challenging that is to speak to people and get judges asking questions. So I just want to praise and applaud all of you for an amazing, amazing job. And I just love all the human-centered aspects of your projects. They were so, it was amazing. I could go on for 20 minutes about how amazing what I saw was today. But I'm gonna kick this off. So let's go back. I want to say, well done. Now keep going. So I have a message for all of you brilliant and creative inventors of Project Event. Once again, my name is Tahira Reed-Smith. I'm an inventor, I'm a professor, and all these other cool titles they gave me at Penn State. But let's move on here. First of all, I'd like to get some interaction. Please scan this QR code if you can, or if you have a text message, basically you could join at this number. But what do you see yourself achieving 10 or more years from now? And I know some of you are like, 10 years, that sounds so far away. Just what do you want to do in the future? What do you see yourself achieving in the future? Take about 2 minutes and just drop some thoughts down. It's going to generate a word cloud that I'll share in a moment. And actually, let me stop sharing just a moment here so I can see what's going on the word cloud. And I'm going to share the screen that way. Okay. Let's see. All right, it's coming in. Okay. I'm not going to show it yet because I don't want to bias anybody. I want people to just anything. Oh, how sweet. Someone said something that's related to what I listened. Give me some more. I only see 4. Oh, it's all coming in. Okay, so let's see. Can I do show results now? All right, because I have 20 minutes, I'm not gonna belabor this. So let me just share the screen again. Wait a minute, am I still sharing the screen? Oh, here we go. All right, so this is what I see coming through the Slido. I see graphic designer, I see entrepreneur. Someone just says like they want a career, industrial engineer. Just see what else is coming in. Family, Air Force medic, then bioengineer, computer engineering career, canine officer, just tons of cool things. Happy, absolutely. Awesome, awesome. Okay, great. I just wanted to get a feel for what you all are thinking about there. And then I'm going to tell a little bit about my story. And hopefully I don't bore you all. If you get bored, put in the chat to say boring. Let me know, okay? All right, so let's move on from here. Tell you a little bit about myself. All right. So these are all the cool things that I did. Once I graduated from high school, some of you are in high school now, I went on and I became a mechanical engineering major. I went on and got a PhD. I did all these things. I became a professor. I worked with NASA for a while. Now I'm a professor at Penn State. And when I look at my overall journey, when I was sitting where you're sitting right now, I never imagined the fullness of all the things that I have been able to achieve. So all those goals and dreams, some of the things you said, it's just the tip of the iceberg, okay? And what I realize is that life has just been a series of taking the next best step. I bet in your design process, a lot of the times you just had to do the next best thing. And I want you all to look at this project invent experience and see there's an analogy for life, how you can use this, okay? And so when I think about a lot of things, like even who I am as a person, all of you had such novel, creative input to your projects. And I bet it's because of a variety of things, not only your education, but where you're from, your family, your identity, all of those things matter so much. And as a college professor, who some of you will be in college in a few years, these things matter when you show up in the classroom, right? And so for me, I realized, I didn't know this at the time, but when I look back, I'm like, whoa, all of this stuff matters. So now I'm gonna share some fun pictures, okay? This is me. I'm from Bronx, New York. This is me when I was little. This is my family. I have Caribbean family, Jamaica specifically. I was first generation American, and I grew up in an extended family. I didn't have the traditional nuclear, like mom, dad, siblings. It was me, grandma, grandpa, my mom, her sister, my uncle. That's how I grew up in New York. And at a very young age, I just loved playing with this toy car. I used to carry it around like a doll. And I know it's a stereotype to say mechanical engineers fix cars, but it was funny. I used to carry this thing around like a doll. And then, I found out that I'm a little bit more interdisciplinary. And I see myself playing with this car again, a small one, and then this little teddy bear thing. I was like, maybe I'm a mechanical engineer that cares. This is supposed to be fun. But I will tell you this one thing. When I was growing up in New York City, double Dutch jump rope in the 80s was a huge, huge thing to do. This is just what kids, especially girls in my neighborhood, did all the time. And I learned at age 5, okay? And I was an only child at the time. So when I got to 3rd grade, I got to participate in a poster contest at school. And the question was, draw a picture of something you wish you could have. I didn't have Project Invent, where kids would come to my school or come and meet with me to help me realize this idea and find out my problems. I had to just draw this picture. I said, I want a machine that turns jump rope for me, a double Dutch, so that I can play double Dutch anytime I want to, not just when I got to school. And at the time, the other kids in my class, they were drawing pictures of the space shuttles and astronaut suits, because what happened right around that time was the Space Shuttle Challenger disaster. And for me, I was like, I wasn't really moved. I don't think I understood what really happened. I just knew I wanted a double Dutch jump rope machine, okay? And then I went on to middle school, and I didn't think about the idea, but I participated in competitive double Dutch jump rope. I got a really great math and science foundation. I just loved math. This is when math just became my friend. I just loved math at this stage. And I went on to high school. I went to this Catholic high school in the Bronx called Monsignor Scanlon. And again, didn't think about the idea, But then a guidance counselor told me about this college called Rensselaer Polytechnic Institute. And so I applied to them as plus others, and that's where I went. So here's a funny picture. This is what I look like when I was in high school, okay? I went to Korea. I did all these cool things in high school. And then that's my graduation picture. And I just wanted you guys to see how I used to dress back then, right? Just Air Force One Nikes. This was how I was, but I was this super smart, love school type of person. But Rensselaer is where things come back to life, all right? So this is where I'm studying mechanical engineering. I am now in a design class called Introduction to Engineering Design. And the theme was challenging the limits in sports and recreational activities. And I started thinking about basketball and football and all the obvious ones. And then I had this crazy aha moment. And I was like, oh my God, that idea that I had when I was in 3rd grade. And so I got to work on it. And so this is what all happened, just a timeline of things that happened over a span of about 3 years. Okay, so let me just make this one comment. The first prototype that was built way before you were born, 1997, it didn't work well, guys. It did not work well. And so I kept trying. I got some grant money. This is why I say keep going. I got grant money. I did all of these different things, and finally it worked. And then the New York Times wrote an article about it. Patents, an inventor makes good on the 3rd grade notion. And then things just kept taking off, right? All of this is the first time the machine worked. This is a photograph. This photo is actually now hanging in the Smithsonian. This is the first time this machine actually worked, and they caught it on camera. And Bert Swersey is my mentor that was standing behind me, and I've been taking his classes the whole time, right? And so all these cool things happened, and I thought this was it. I was like, okay, great. I was in the news. I was on the Today Show. How cool is that? But it didn't stop there, okay? Got 2 patents. Got 2 patents for these ideas, for the idea and an improvement on it. Yet there will be another one coming forward. And I even got featured in this children's book. There's a chapter called To Hear or Read Ben Franklin's Answer to Double Dutch. It just goes on and on and on. And so what happens next, right? I go on and I get a master's degree. I start a PhD. I do a postdoc. I become a professor. All of that stuff happens, okay? And people want me to talk about this story. And here I am, a professor, and they want me to talk about this thing I did as an undergrad, okay? They didn't want me to talk about the research. They said, talk about that double Dutch machine. I even visited kids in school telling the story of this thing, okay? And then how about my story got featured on a New York State standardized test for 4th graders. I did not even know this. And so the story just keeps unfolding and unfolding and unfolding. And this was a funny excerpt about the book, but I'll just pass it on. But then here I am now hanging in the Smithsonian in an exhibit called Change Your Game. And I also finally now have a company in San Jose called Spec Design helping me to build market-ready versions of this invention, finally. And I also did some filming for PBS in just in February of this year. So let's just pause for a moment. Let's remember, put in the chat, how old was I when I had this? I want to do a chat storm really quick here. I'm going to look at the chat. Chat storm, how old was I? What grade was I in when I first had this idea? Let's see if you're paying attention. Chat storm. So I'm going to count to 3 and start. There you go. 1, 2, 3. Chat storm. Come on. Type. Yep. 3rd grade. Right. Okay. Perfect. All of this happened with this one idea. Now I've worked on other things. Yep. Probably 8 years old. Exactly. Right. I worked on all these other things, but this has been a constant. And so I want you to know that you can live your dreams too. However, challenges can come. Another chat storm. What are some challenges that maybe could come along that could easily hinder things from happening? Maybe in your projects, did you all face any challenges? If yes, put them in the chat. What are some challenges that you might have faced in the chat? So I'll count to 3 and then we'll do a chat storm. 1, 2, 3. Put in the chat. What are some challenges that could have come along the way either in your journey or my journey, that could have made this almost impossible? Everyone's so quiet. Oh my God, I hold my question. No one's typing. Okay. All right, that might be. The tech can be so tough. Lack of knowledge or experience. Absolutely. The patent process. Funding. Absolutely. Yes. Absolutely. Yeah, and I mean, beyond that, in the journey, there were all kinds of life challenges that came along the way. Let's not talk about when I went to undergrad and, yep, money negative people. I went to undergrad and one semester was so hard for me, guys. It was so hard. I got like an F and a D. I can't remember. All I know is that I was on academic probation, which means you have one more semester to get it together. Oh my gosh, that was tough. Had a health challenge. I had to like have a surgical procedure. People passed away. There was all kinds of things happening with family and relationships that was so challenging, right? And talk about money and negative people and so many other things. Life happens, but the key thing is no matter what, you have to keep going. And these things happen all along the journey while I was working towards every career, like the career path, this project, all of that. And I just want to encourage each of you, number one, commit to never giving up on yourself, your dreams, your potential, and your worth. You must commit to those things, okay? Number two, I don't know if you've heard the saying, it takes a village to raise a child. I strongly believe it takes a village to do anything great. Absolutely. That is I believe that with all my heart, okay? Make sure that you're keeping some wise people in your village, and I highly encourage intergenerational members in your village. What does that mean? Whatever age you are, make sure you have some young and older people in your village. So for example, my goddaughter is 16. Sometimes I ask her questions, be like, hey, can you tell me a little bit more about this? Because I want to understand your generation, what's going on. And then I've got people way up in their 80s in my village that I like to hear about life, how it was, and just get some perspective. And lastly, always look forward to the next best thing. Where do you go from here, right? The title of this, well done, but keep going. What is your next best thing to do with your ideas, with your dreams and aspirations that you shared ahead? Anything, correct, and take the next best step. If you make a mistake, fix it, heal from it. No one's perfect, and you just keep going forward, okay? And so I want to end here and take any questions that you might have. I think I have a few more minutes that maybe Carrie or Jax can let me know if I could take some questions, or did I run out? Am I out of time?
No, we have a few more minutes. So yeah, if anybody has any questions, you can put them into chat or use the little hand raise button and unmute yourselves. That was amazing. Thank you so much.
You're so welcome. I know that was kind of quick.
Hi, I have a question.
Yeah. Okay. And I'm gonna.
So originally starting out when you were like still understanding yourself, how did you network out to other people to get your ideas started?
Say the first part of the question.
You were starting out.
When I was starting out third grade, or
like when you were starting out, like wanting to make your ideas come to reality, how did you network out to make it a reality, basically?
Okay, so the good thing was by the time I was in undergrad, I happened to have an instructor who he himself was an inventor and a serial entrepreneur. And so I was taking this design class, and his voice was very important because he knew a lot more than I did at the time. He introduced me to his patent lawyer, and he was also very encouraging. I saw that comment in the chat about challenges being negative people. He was one of the positive people. And so he helped me get connected to people and resources. Now, your question, now let's say you're like, hey, I'm not going to be in college until 3 more years from now. It's powerful that you're part of this community called Project Invent. I bet if you have questions about the very next thing to do, you could easily consult some of the organizers and leaders of this program to help you figure out what's your next best step. Back then we didn't have Google, so you might even just look up some things on the USPTO website, things of that kind. Depends on what your question is or what you're thinking of or where you're at, but definitely consult people that, yes, now you can add Dr. Reed. Yes, that's right, in the network. That's right. So any questions you can absolutely ask someone. Let me not belabor the point. Okay. Oh, you could come off mute and unchat. Let me just try to see if I could see everybody. Everyone might be tired from a long day of preparation. And I know the judges are deliberating on, how you all did, but just know that no matter what the outcome is, you still keep going. That is the main thing. And that all of your ideas have I just saw such novel, really cool and heartfelt ideas shared today. And I was just so pleased. And it just made me say to myself, oh boy, this is why when these students come to our colleges, they have high expectations about what design is going to be and should be. So, oh, I think I saw a hand. Oh, no. Okay, I see a comment. Let me scroll down, scroll up. Can't see the top of it. As a mechanical engineer, were there areas like electronics or manufacturing that you didn't have any experience necessary for the problem? If so, how did you tackle them? Let me scroll it down. I can't do this. My chat is not scrolling down for me.
It's okay. It says, did you study them yourself or rely on connections with people who are already knowledgeable?
Okay, perfect. Thank you. I'm going to use the chat on this camera. I think this is probably going to be easier. Okay. Yes and no. So mechanical engineering is a broad discipline, and we actually get some exposure to electronics and programming, wiring, all of that. So you're not completely absent from that knowledge set, but what you will find is that in departments, universities, they have support staff. So there was someone there named Jerry Zuba, for example. He was just amazing at electronics, and his role was to support students in their projects. So if questions came up, he could bring his expertise. And for example, when I had to go on the Today Show, I refused to go on the Today Show without Jerry. I was like, Jerry needs to be able to come on this trip as well, because he had actually built the power supply that I used for that prototype that was demoed on the Today Show. It's on YouTube. It's an old video. It was like a VHS converted to a digital format. And so you might see him in the background. So yes, to answer your question, if you're lacking that, there's probably going to be a resource around you that can help you with that. Oh, I could see another one. Can you tell us more about why you pursued a patent? So cool thinking about all the patents possible with our project student inventors this demo day. Keep going. Okay. One of the reasons, so again, my mentor at the time, he was knowledgeable, and that first patent, he just thought the idea was novel and that it should be protected. And then I was going to do a demonstration at the Smithsonian, and there's this rule about, public, at that time, it was like first to invent. Now it's first to file. Okay. But that was where the source of the encouragement came from. And plus where I was at school, there was a strong entrepreneurial culture there. And so I was encouraged to pursue the patent. Utility patents help to protect sort of the functionality of a thing, and design patents are sort of how it looks. And so, yeah, so that's where that encouragement came from. And I think talking with like an IP lawyer, some people like that can help you identify what's novel or where you can establish claims on ideas and to ensure it is actually patentable. So the loose definition that I remember learning is that something is patentable if it's not obvious to someone skilled in the art, which means you developed something that maybe it wasn't obvious to another mechanical engineer, it wasn't obvious to someone skilled in design. You came up with something that wasn't obvious to them. And so that's where that novelty comes in. They probably have better language now, but.
Dr. Tahira, I think we are going to move on. I will be talking to you at some point for a lot of different reasons. I have a junior myself who is looking to major in ME, who's also received the Rensselaer Award and is not quite sure if she plans on going there. So I've already connected with you on LinkedIn, so I can't wait to talk.
Perfect. We'll do a Zoom.
And I'm a Penn State grad, so how about that? So
look at that. How nice.
Yeah.
Well,
So
thank you.
Thank you so much for sharing everything you did. I'm sure the students got just as much out of it as I did. But yeah, thank you for, giving us that inspiration to challenge ourselves, and continue on with the journey for sure.
Absolutely. Thank you so much for having me. Look me up online, social media, if you have questions. All right. Take care, everybody. Have a good rest of the event.
Thank you again.
Okay. Bye-bye.
All right. So I believe our panelists are back, and hopefully have made their decisions. I'm sure they were not easy decisions to make. It's time to go over the awards. So we're going to talk real quickly about the different awards that are available. So give me 1 second. Pull this back over to my other screen, and I think we are good. All right, so real quickly, there are 4 awards. There's the Need Finder Award. It's given to a team that really listened to their community partner. The Product Pivot Award is a separate award. It's presented to a team that had to overcome many obstacles. We also have the Moonshot Award, which is given to a team who identified and created a notably creative product. And then last but not least, the Explorer Award is presented to a team that demonstrated a great amount of learning. So again, real quickly before we start our awards here, a quick word to the students once again. What you have done today and in the many months of hard work and innovation leading up to today is incredible. You've built something that few people ever will. You've built something designed to help real people in the real world. And you've done it as a high school or even a middle school student. Okay, that's unbelievable. That's definitely not something many of us had a chance to do when we were your age. All right, you've learned the skills to become the fearless problem solvers of tomorrow. So if you receive an award today, that's obviously very exciting, but if you don't, this is far from the end of your journey. So with that in mind, let's welcome back our panelists. I believe they're in, sorry, I have so many things open on this little screen here, but I believe they're here. So I think there's one more, there we go. So hopefully everyone's looking at the slide now that mentions the different awards and which student mindsets from Project Invent that they were most aligned with. So I will turn it back over to our judges.
Students and fellows, y'all are amazing. Like truly, this was such an exciting and inspiring and incredible showcase to be a part of. So thank you so much for inviting us to be a part of it. I've been a fellow before and I know how much work you have accomplished this year. So I'm personally proud of you. I've never met you, but I'm so proud of you students and fellows. So thank you so much. So I'm going to start with the Explorer Award. So this is the team that really prioritized learning. This is the team that we saw through themselves into learning technology, through themselves into working really cohesively as a team and really did a thorough research and development process. So we would like to award the Explorer Award to Team Hug Tight. Congratulations.
Thank you so much.
I will go next. I echo Annette's sentiment that this was fantastic. The solutions were really phenomenal. The level of depth and rigor was just really, really impressive for so many of these products. So everyone should be really proud. I'm excited to announce the Need Finder Award. This award goes to someone who really listened to their user. When you're designing products, this is the single most important thing. Is listening to the people that are going to use this product the most and what they have to say. So the winner of this award goes to ScribbleMate, which is really exciting. We thought you all did such a great job listening to Peter, hearing his needs and what would make him and others that struggle with handwriting be more effective. In particular, the one thing I was really impressed by was the response around letter spacing versus word spacing, and the fact that letter spacing isn't a problem and doesn't matter. That's the sort of insight that will allow you to build a great product that your users will love. So great job.
Thank you very much.
Yeah, again, I mean, this is my first time here and my first time being a judge. I just want to say this was an awesome experience. Really, you all deserve an award. You did so good. I come from a college background and you're doing work, you know, at that level. So you should all be very proud of yourself. Really good work. So the award I'm going to discuss briefly is the Product Pivot Award. And it's gonna, this was really hard to do, by the way, to pick one. But we went with Team Flint with their Quack Guard product idea. And so you pivoted from, you know, using that pH sensor, and then you switched to a turbidity sensor, and then you realized that maybe Wi-Fi might not have a lot of coverage, and so you're gonna factor in some cellular work and have a backup to save your data to an SD card. So I think you really ran into quite a few obstacles, but you pivoted and you made it work. So congratulations, great work.
Thank you.
You're welcome.
Okay, our final award is the Moonshot Award for the team that had a notably novel or impactful idea. We really focused on the wide-scale impact that this idea and this team's invention had. So we would like to award it to the Joey. We are so impressed that you chose to take on such a massive problem around men's mental health. It has impact across the world and across all of us.
Yeah, thank you guys.
Yes, thank you.
Press to be dressed.
Amazing. Thanks, guys.
All right, thank you so much to everyone. That does conclude Demo Day. Congratulations once again to the amazing teams today, and a huge thank you to our panelists, certainly to Dr. Reed Smith, our keynote, our audience, and any current or future donors to Project Invent. This couldn't be done without you. And certainly to all the fellows, my fellow fellows who helped these teams along their journey. I know it's a lot of work from doing it for 3 years, but keep up the good work and keep on keeping on. You can continue to donate to Project Invent in the future to continue their mission of empowering young people to innovate all year round.
Amazing.
So Carrie, I'm going to turn it over to you.
Thank you so much, Matt, and thank you for being an absolutely amazing MC today with our with this main room. Thank you, and to our judges. We had to have our other team judges pop off, but we would like to announce the other team winners while we're all together. So I'm going to pass it to Kate to announce the 2 awardees from the other room.
Hi, everybody. I just want to reiterate what was said already. It's been such a privilege to listen to both the middle school and high school pitches today, and I was so impressed with the amount of dedication and work that was put in. So our middle school judges decided on 2 award winners. We had 5 middle school teams present today, and we were impressed with all of the ideas and all of the hard work that went into all 5 projects, but we're going to be highlighting 2 now. So our first award is going to be the Explorer Award to a team who prioritized learning. And our judges decided to give this award to a team who they felt crushed their question and answer session and had a great pitch presentation with thorough research that highlighted learning from the beginning through the end of the process. So the Middle School Explorer Award today is going to go to Team Foldify. So congratulations to Team Foldify. And then our second award for the middle school participants today is going to be the Need Finder Award. So again, the Need Finder Award goes to a team who really listened to their user and took into account what their community partners' needs were. So the middle school judges selected a team who came up with a unique idea that was incredibly helpful for people with multiple types of disabilities. This team really listened to their community partner during the design. So the Need Finder Award for the middle school group goes to Team Gameable. So congratulations to our winners and to all of our teams. Again, fantastic job, everybody.
Awesome. Thank you, everybody, so much. And Matt, if you want to close it out, I'll let you take the floor.
Absolutely. I'm assuming you can still see me. My screen has gone so bonkers that I don't know if I'm on or off. But again, thank you. I've been in education for nearly 20 years now. And I told the folks at Project Invent 2 years ago when I was able to take one of my groups out to Future Fest that this is by far the best thing going on in education across this country right now. And I stand by that 2 years later. So all of you at Project Invent, thank you very much for all that you do for all of us and students. Once again, keep fighting the good fight, and hopefully we'll see you on the Today Show or on the news or in a book or on the shelves sometime soon. Thank you again, everyone.
Have a great weekend, everyone. Congratulations. Amazing job.
Congrats, everybody.